knows who Rob is already. I've got no chance once AI gets going. I'm useless. So here we go. Rob Allen, everybody.
Thank you. I absolutely love a round of applause before I start my speech. It makes me feel good. Right, hands up if you've got an empty chair next to you. Right. There's some people standing. There are a few seats if you want to sit down. So it's very gratifying seeing so many people here. That's awesome. Okay. The clue is in the title of the talk. We're going to be talking about HTTP APIs and the styles of them. I'm an API consultant, so that's a very fancy way of saying that I'm self-employed and need work. So if you need help with your APIs, I'll get the spiel up while you're a captive audience. Come and see me, talk to me, I can help you with APIs, and hopefully you'll understand a little bit about the way I think about them during this talk. So, first thing about APIs, and my approach to APIs, the way I think about this stuff, is that your API has to be fit for purpose. That trumps absolutely everything. The API has to do its job. It has to do its job well. It has to meet the business requirements of what we are writing this API for. That is vital for an API to be successful. And we're interested in what it takes in terms of the architecture, how we build this API in order to create a great developer experience. I'm going to look at the different types of architectures in this talk. I'm going to look at their strengths, I'm going to look at their weaknesses. If you've already used all three, there's going to be a lot of redundant information in here. So, API architecture. We're looking at three types today. So as by clear on the talk title, we're looking at GraphQL, we're looking at Restful, and we're looking at RPC. They've all got pros and cons. Which you pick depends upon which particular pros you care about and which particular weaknesses are less important to you. But don't think that there's a panacea here. There's no perfect solution. Pick the one that works best for your particular situation. So let's start by looking at how they work. APIs can be realized in any style. Pick the one that makes the most sense. We'll start with the RPC. These are the original APIs. This is where we started back in the beginning. We created the first HTTP APIs were all RPC based, and they're still current. Very, very loosely, the mental model is you call a function on a remote server. So we write functions, we write methods, and whatever on our code base. We want to call one that's on a different server, we make an RPC call, a remote procedural call. Clue is in the name. Some common implementations. JSON RPC, XML RPC back in the day, SOAP, gRPC. Has anyone here written a SOAP API? Yeah, a few people. So, had I asked that question 10 years ago, everyone would have put their hands up, and they would have all groaned. That's most definitely in our past now, mostly. Unless you work in legacy, in which case it's most definitely in your future. Tends to require a schema. The obvious problem with a API system where you're just making a function call onto a remote server is how do you find the name of that function to call? How do you find its parameters? And this is a relatively old technology in the grand scheme of things, so the way we do it is we write them all down, and we call that written down document a schema, because it sounds more impressive. The other thing about schema, the word schema, implies that we can machine read it. So one of the nice things about RPC APIs is they are particularly good for consuming into code generation to create a class in your local app that's got all the function names for the remote call, which is one of the reasons why SOAP was so popular. It was quite good at that. We're going to use JSON RPC as an example because the payloads are remarkably short, so they fit on my slides well. If you could imagine this being SOAP, there would be 700,000 more lines of XML here. And nobody wants to see that. Ethereum, it's a blockchain-y thing that's around, but it's using JSON RPC. And I found that quite interesting, because Ethereum is quite new in the grand scheme of things. You know, they had a choice of which API architecture to pick. It wasn't a situation where SOAP was the only choice. And they chose JSON RPC. They didn't choose REST, they didn't choose GraphQL. They picked JSON RPC, which is quite interesting in this day and age. And I think they mostly did it because the way they think about the way the blockchain and the way Ethereum works is quite transactional. It's quite fits very neatly into the concept of a function being called on a remote service. So that's the way they designed their API. It fitted their mental model of how they operate their system. This is how you do it. So we've got a post request. Absolutely every RPC system does post requests. So you're going to do a post request to an endpoint. The endpoint will be the same endpoint every time. And for this one, it happens just to be the root /. And then you're going to send some sort of payload. The payload is going to contain the function you want to call and the list of parameters for that function. In this case, we call it a method called net_peerCount. Naming is always hard. And there are no parameters to list call, so it's quite a simple one, and we send that over the wire, and we get back a response, and you get the result. So it's literally a function call on another computer. Dead simple. That's one of the nice things about RPC basic APIs. It's a little bit of metadata there. So we've got an ID and we've got this JSON RPC version 2 parameter in there, so we can change our schema over time if we need to. That's quite handy, but not complicated. gRPC is a more modern RPC system. And way more complicated. It was invented by Google. I'm not going to put correlation there. It's very highly typed, and we like highly typed nowadays. JSON RPC is not remotely typed. gRPC is very highly typed, which makes quite a lot of sense. Again, if you start thinking about calling a function on a remote server, we probably care about types in our code base. It's nice to care about types in our remote calls as well. Downside of that is you need lots of code generation for this to work. So gRPC does depend on code generation, and it uses a binary protocol over the wire, which means you cannot inspect it remotely easily. It's quite hard in that sense. On the flip side, it's really efficient. Binary protocols are more efficient than text-based protocols. Particularly now we can't really gzip stuff with HTTPS for vulnerability reasons. So that's good, we like that. There is no browser support as a result of this whole binary thing. Works really well in some situations where you control both ends. Google likes it a lot for their internal stuff. That's RPC. RESTful APIs. Who here's built a RESTful API? Yeah, a lot more people. This is the common HTTP API as we call them today. There's a whole load of complexity around REST and how evangelical some proponents might be. I'm a pragmatist. Well, I need to get work, so you can't be too evangelical. And it doesn't really matter in the grand scheme of things. So there are some key things about RESTful APIs that actually do matter for creating a good one. And one of the key things is that it depends upon HTTP as its fundamental semantics. And that gives you a lot of power in your API because it works the way the web works, which can be really, really helpful for understanding how it works and for leveraging the power of the web and the internet in general. So this is the way we phrase it. Operates on a representation of the state of a resource through HTTP verbs. So REST, representational state transfer. This came from a PhD doctorate type paper, and you can tell by some of the words they use. We're going to talk about verbs, so we're going to do get, post, put, delete, patches, things like that. We're going to use the whole gamut of HTTP here. It's HTTP native, so we can actually use different URLs for different resources. We're going to care about status codes and things like that. What's this concept of a uniform interface? Now this is starting to get to the bit where the less experienced people start falling off the Restful bandwagon and end up with an HTTP API. Uniform interface implies predictability, predictable endpoints, predictable operations, and makes your API much easier for other people to understand and operate with. It's a really good one to get right. What's this concept of hypermedia controls? Now this one you don't have to care about, but if you want to be completely RESTful, then you're going to have hypermedia controls, which again, you can tell it came from a doctorate type thesis, because that merely means links. But hypermedia controls makes it sound more professional, but we just talk about links. If you have a resource and you put a link to another resource, you have created a hypermedia control. We do it all the time in HTML. We can do it in our APIs. It creates discoverability. Discoverability enables your clients and your people integrating with your API to be more decoupled from the actual API implementation. Now, decoupling is good. If you weren't here, a good proportion of you would be upstairs in Ian's talk. Who's talking about dependency injection? Whole point of dependency injection? Decoupling. In APIs, we decouple using hypermedia controls. We enable the server to tell the client where to find the next piece of information. So if you want to move things around at the server level, the clients will all just follow and not break. It is a really powerful feature. It's also extremely difficult to get right, which is unfortunate. How's it work? You've all seen this because half of you have done RESTful APIs and the rest of you have all integrated against one by now, because nearly all of you have probably done something with Stripe. This is a put. We are putting to a URI endpoint, /user /some random number. The method matters. This is a put request. So we already know the full URI to this resource. Otherwise it will not work. We're either creating it or we're going to be updating it. We're definitely not going to be deleting it. We're not retrieving it. We can tell that just by what method we're using. So that's how we're using the semantics of HTTP. We go pass some data, because we're obviously going to do an update or create or something. So here's the data we're going to send. Not very imaginative. My user's got a name and my user has an email address. That's the email address to email me on if you've got work. And we've got content type. Another nice thing about HTTP is that it's extremely well designed. Lots of really, really smart people thought about how to build HTTP. That's why it's lasted 25 years and it's only on version 2. I'm just saying, Firefox came out with 110 recently. And God knows where Chrome is now. But we're on version 2 of HTTP because it was incredibly well designed as a protocol. It was very extensible, did not need a lot of change. And the reason is the way headers work. Content type, application JSON. We have an extensible method to change our body and allow our server and our client to speak the new type of formatting. Right, JSON wasn't a thing when HTTP was invented, but we can transfer JSON bodies. We didn't have to reinvent the protocol. HTTP is really clever. I like it a lot. If you don't send that content type, your server has got no clue how to decode this body. Don't ever forget it. And finally, back to HTTP and the whole concept of expectations, we tell the server what format we can read. So a really good API, a RESTful API, you could set that to application XML. And even though you posted or put some JSON, the API could return you XML, because that's how you would like your data to be returned to you. HTTP and RESTful APIs are the only ones that you can do that sort of type stuff with. And you get response back. We get status code. That status code matters in RESTful APIs. Do not get that bit wrong. 201 means it's created, so with that put request actually created a new response. It would not have sent a 201 back if I was doing an update. So if I repeat my put request, I will probably get a 200 back, or probably a 204 or something like that. I will get a different status code back to tell me what happened. Given that I'm sending the same data every single time, I'll probably get not modified. But the semantics and the expression available on the status codes enables the client to work out what's going on. Again, we have our body. So this is a convenience. There's no requirement for the server to send you back some data, but this server is pretty friendly, and it has sent back my data. It's told me my name and my email, even though I sent them in the first place. And it's also given me the canonical URL to this particular item, and that's the hypermedia controls bit. And lastly, it's set an e-tag. Here's where RESTful APIs leverage the power of the infrastructure of the internet. So e-tags allow us to detect edit clashes. So when I go and retrieve a resource, like I retrieve this user, I get an e-tag. That e-tag is unique for this particular version of that particular resource. So now if I go and send that data to do an update, if the e-tag changes at the server's level, the server knows that someone else has done an edit. So we can detect an in-flight edit clash. And that could be quite powerful. It also allows us to avoid sending too much data around over the wire. So if I've got the e-tag, I already know essentially a hash of this data. I mean, that tends to be how servers implement it, but really it's just a random number. What I can do is I can send the if none match header with that e-tag on my GET request, and my server can respond saying, you've already got the best data. The data has not changed since you last asked for it, so I'm not going to send it to you again. So if you've got slow internet, and I appreciate we've all got super duper internet here, but if you're somewhere that's maybe less infrastructurally wealthy as we are, you might have much slower internet. Avoiding sending that cat GIF a second time could be saving a sensible amount of bandwidth that that user is actually paying for in actual money on their mobile plans. So you can do that quite easily with RESTful APIs. And pretty much you can only do it with RESTful APIs because you need to use GET semantics in order for that to work. Okay, so that's RESTful APIs. GraphQL APIs. These are the new ones. Has anyone implemented a GraphQL API? Oh, more people than I expected. Cool. Did you do it in PHP? Far fewer people. Interesting. Has anyone integrated against a GraphQL API? Actually tried to talk to one. Cool. Same people plus a few extras. That's interesting. They're the modern one. They're the new one. So they're probably about 5 years old now. Something like that. GraphQL APIs were invented by Facebook to solve a problem they had, or at least a problem they thought they had. It's difficult to tell the difference at times. The key thing they cared about was the data traffic over the wire. That's what they really mattered to them. And they also wanted to give their mobile app teams more control over the features in the apps. So that was the main driving forces behind the reason GraphQL came out. So it's worth bearing that in mind, that those were the problems that were trying to be solved. So one of the key tenets of GraphQL APIs is that you can retrieve only the data you need. Okay? And most importantly, you specify it at the client side. So the client chooses what they want to receive. The other tenet is they reduce the number of calls required to retrieve embedded or sub-data. So if I want to pick up an author with all their blog posts, with all the comments for all those blog posts, I would like to do that in one call. GraphQL is intended for that to be possible. A RESTful API is less likely to be built that way. you're likely to want to retrieve the author, then retrieve the collection of posts, and then retrieve the collection of comments for each post. So you can see there would be more HTTP traffic with a RESTful API built in a relatively naive way. GraphQL was explicitly designed to avoid that problem. Introduced other ones, but it definitely designed to improve that one. And the other thing they invented, or came back to, was the concept of self-describing schema. One of the problems with a RESTful API is that the documentation is independent of the RESTful API itself. So if you want to know exactly what parameters a given property on RESTful API is, you probably going to need to read a separate spec. The idea in GraphQL is that you can query the API itself and it will tell you that information. You'll notice that's not a million miles away from what we did in the RPC days. So a certain amount of coming back round again. Okay, this is what it looks like. So there are two ways to interact with the GraphQL API. You can either read to it or you can write to it. So this is reading, that's called queries. This is a DSL. It looks vaguely JSON-like, but it's not JSON. You'll notice there's an awful lot less semicolons and commas and double quotes and things like that. Here's a query. We've bound the thing in the query tag. We're going to ask for the author. So now I'm going to get the author. I have to say which author I want, so I pass in the name parameter. To find out that I can pass in a name parameter, I have to go and query the schema to find it. Now I've got it, I'm asking for Anne McCaffrey. Here's where I specify the particular properties I want back of that author. So I want ID and name. If I don't specify anything, I get back nothing. It's not going to guess for me, you'll get back nothing. Now I want some books. So this will be all the books that Anne McCaffrey has written, but I'm going to limit it to the first 5. There are a load of conventions around the way you structure your GraphQL queries, and collections will tend to be pluralized, whereas individuals will tend to be singular. So by asking for author, I know I'm getting one back. By looking for books, I'm going to be getting a collection back. It's really, really common for a collection to have some sort of limitations on it in terms of pagination. So you either need to say how many you want in each page, or whether you want the first 5 or the last 6 or whatever. Some way of limiting the scope of the collection you're going to get back. And again, you have to specify which properties you want. So in this particular case, I want the total count of the collection. Not the books, the collection, because we are at the collection object at this point. So how many books has Anne McCaffrey written should come back as total count. And then I ask for each individual book. And here you start seeing the graph bit of the GraphQL turn up. So if you know your graph theory, edges and nodes is the way you tend to describe graphs. So we have edges and nodes in our GraphQL, and the node represents each book, and I'm asking for the ID and title of each book. And I get a response back. Responses look something like this. Again, it's going to be a data at the top. So everything comes back in the data block. And there's my author, and there's my ID and my name, because that's what I asked for. Then I get my list of books, and I get a total count of 6, which incidentally is totally wrong, because I could only bother to load 6 books into my test database. In practice, Anne McCaffrey's written far more books than that, and they're really good. And then we get our edges with our nodes, and each node is the book itself. And again, it is the data I asked for. And that's how we get data out of GraphQL. The other way around, we call them mutations. A mutation is either going to do a create, an update, or a delete. It obviously lives within the mutation tag or structure. It's a create author. This looks a bit like a function call. So again, we've got a name and I've got date of birth. That's the data I want to create my author with. And then I have to tell it what I want to return back again, because the client always chooses the data it gets back. And you get a response that looks something like that. It looks pretty much the same as you'd expect from the other example. You've got the data block, you've got the create author, you've got the returning tag, and then you've got the data itself. And I created Mary Shelley with its own ID. Okay, that's the 3 types. So you've now got a fairly good overview of how they all work with any luck. Which one are you going to pick? Here's where I start copying out a little bit and put on my consultant's hat. And I tell you, it depends. And I tell you that it's up to you and that I can't make the decision for you because you're the one who has to live with it. I'm mostly a pragmatist. Pick the one that works well, and here's some thoughts about it. Yeah, pick a Lamborghini or a Ferrari. This is a preference. Doesn't really matter in the grand scheme of things which one you pick. They're both going to go quite fast. They're both going to be fairly brightly coloured. They're going to be very loud. They're basically going to do the same thing, but they're just made by different people. It is totally valid to pick the API structure based on your preference. I give you permission. You can build a GraphQL API because you think it's better and no other reason whatsoever. I just like it. It's a perfectly valid reason to pick an API choice. Mind you, nobody's picking soap. What about Lamborghini or a truck? This depends on what you're optimizing for. There are some scenarios where it's better to have the Lamborghini. If you want to go really, really fast, Lamborghini is probably the better choice. If you want to carry a lot of stuff, the Lamborghini is probably less good as a choice. Now there are some important differences between the types of APIs, and those differences might matter to you. In which case you should pick the one that fits your use case. Pick the truck if that makes more sense for the situation you're in. And that's why Ethereum picked JSON RPC, for instance. It made more sense for their particular requirements. So what are some of these important differences? You probably got some fairly good ideas from our discussion of what we talked about and how they work. And these are the basic considerations. What's it going to be used for? Do we need to be able to customize the response at the client end? Is that a requirement? How are we going to do that? Do we have HTTP interoperability requirements? Do we have developer experience requirements? Things like that come up. Do you control both the server and the client? That makes a big difference. If you're doing something like gRPC, owning both ends is much easier to think, gRPC is the right tool for this, than if you need to actually hit every single web developer in the world. Right? There's a reason Stripe doesn't use gRPC, for instance. That would very much curtail their business. And that would be bad for them, so they don't do it. How many users are expected? That has a factor on the sort of load you're looking at. Where do you want to put that load? If you're Facebook and you're hitting 2 billion people per day hitting your servers, you probably have different thought processes on how much CPU processes per API call matters compared to a user or a system that's only got 100 users. Very different calculus at that point. Maybe we actually want to leverage all the CPUs of the mobile phones and do as much processing there as we possibly can, because there's 2 billion of them that we didn't have to pay for. And of course, we don't care about their battery life. Equally, maybe you do care about your user's battery life on their mobile phone, and suddenly putting a whole load of processing on the phone is less wise. Depends. Say, skill level your integrators. There is no point in coming up with an API that the people you're targeting can't actually write against. That is a bad business decision, because you need people to use your API if you're going to succeed. Again, if you know the server and you know your client, then you've got more control there. Response customization. GraphQL is a query-first language. That's its point. You have to pick the fields. You have to pick your nested resources. That's really, really powerful if you want to give that amount of control to your clients. Because now your server has less control over what they're asking for. REST, it works the other way around. You tend to prefer separate endpoints for sub-resources through HTTPS. HTTP2 helps things a little bit, but it tends to be a different mental model as a result. Sometimes you can use a DSL, such as JSON API or something like that for customization, but they tend to be sort of layered on top of REST in some way or another, and maybe don't fit quite as well as with GraphQL's query-first nature. HTTP2 is awesome. We should all be using it by now. Whether we are or not, I'm not judging. But it does allow for multiple requests in parallel over the same TCP connection, which does resolve one of the key problems that GraphQL was trying to fix, which the setup and tear down of a TCP connection is relatively slow in the grand scheme of things. So if you need to make 20 of them, 20 setups and 20 teardowns is quite a lot. But if you can open the TCP connection once, make 20 calls and then close it, your performance difference is nowhere near as big. RPC, completely different mindset. You're calling a function on the other end of the wire. If your responses and your problem space, that makes sense, then you should be looking very detailed, very strong look at RPC. State the blindingly obvious, none of these will actually fix your database. None of these will fix your application design. That's still on you to get right. And arguably, that's the actual problem with most slow APIs. It's rarely the API level, it's mostly the application level where you want to do your work for efficiency. About performance. That's another philosophical difference. REST and RPC are server performance first mental models. The server is in control. GraphQL, client performance is most important, it's paramount, and the client is in control. That makes a very big difference to the way you think about your API and the way your integrators think about your API. Caching. Do you care about caching? Does it actually matter? Now that is a question in and of itself. With GraphQL and RPC, you will cache entirely at the application level. Very, very loosely, once you've gone and retrieved that expensive data query out of the database and all your business logic, you can drop it into Redis or something like that and pull it out really quickly for the next request. You should do that for your Restful APIs too, because that is an application caching level that everyone should be doing. REST can additionally cache at the HTTP level for GET requests, because that's built into HTTP. It's a natural consequence of using the internet's natural language. Do you care about that? Does it not matter? If it matters to you, then HTTP RESTful APIs, you get a feature for free. Data transfer. Side by side here. So on the left, we've got GraphQL. We're retrieving a user's avatar. So I'm looking for the avatar object. I've got user ID of 1234, which is clearly designed to fit onto the half of a slide. And I get back a base 64 some data, and I'm told its format is image JPEG, and now I can display my user's avatar. And I could do exactly the same thing with RPC on the right. I post to /API, the method is called getAvatar, pass in the user ID as a parameter, and I get back my result. Again, base 64 data. What about REST? I get more choices here. I can do exactly the same thing. If you look on the right, I'm doing exactly the same thing. Get to /user/1234/avatar. I accept application JSON, and I get back my data base64 in a data property by JSON. But on the left, I can set the accept header to image JPEG, and I get back the raw JPEG data. You can't do that in any other API structure system. Whether you need it or not is another question, but that's quite a powerful feature. I can have the same endpoint and retrieve the CSV version of that collection, or I can get the PDF report out rather than the HTML report just by changing the accept header. So I get that flexibility, again, built into HTTP. What about versioning? One of the big things about GraphQL, and GraphQL is new, so the evangelists, let's call them that. The evangelists for GraphQL are quite vocal about its benefits and what they see as the perceived downsides of the other API choices. One thing you'll see quite a lot of is that GraphQL doesn't need versioning. You will hear that a lot. They're talking rubbish. Every API doesn't need versioning if you do it right and are really, really careful. Practically, none of us are. And if we go back to the keynote this morning about building on the ruins of things as we learn them in our cities, it's exactly the same thing with our applications and with our APIs. We don't actually know what the future's going to look like. It's really difficult to predict the future. If you could predict the future well, you would not be in this room. You'd be probably sitting on the beach somewhere, enjoying yourself. Versioning comes because we discover we made a mistake in the past, that the only sensible way to fix it is to change and break backwards compatibility. It happens at all layers of software. We always hate it when a dependency breaks BC because it gives us work to do. I really dislike the fact that PHP unit evolves by doing BC breaks. I quite like the new features I get though, and that's a tension that we always have. So RPC, Graph, and REST can all do API evolution. It's not difficult. You can invent new methods or new functions in RPC which have new properties so that you don't have to break an old method. You can do the same with REST by creating new resource endpoints, or by using a different accept header to send back a different representation. And you can do the same with GraphQL. It is all very much possible to do good BC conforming evolution of your API. You can also break APIs and break backwards compatibility in all three trivially without noticing it in a code review. So put good integration tests in. That's a great way to find BC breaks. RPC, obviously quite easy. All we have to do is change the meaning of a property or parameter in a function call, or add a new non-optional one. That's another great way to break BC. RESTful, same thing. We can rename a whole load of properties without telling anyone. Guess what? You can do the same in GraphQL too. GraphQL is self-describing, so hopefully you can go and find this out. RESTful APIs tend to use open API specs, so again, hopefully you can find this out, but it is most definitely a BC break. Definitely possible. One thing GraphQL is really good for, though, is handling deprecation. So over time, as your API grows, and you've got your resource, and you've got your properties on your given object, you might want to get rid of some of those properties because they're old, they're no longer used. You had a timestamp that was a Unix timestamp, and now you provide a better format with time zones or something like that. So you want to get rid of the old one. How do you know you can get rid of it? So you've marked it as deprecated. It's in all your documentation, deprecated. So clearly no one's using it, right? Nobody read that piece of the documentation. Well, nobody read most of your documentation, but that's a different question. One of the nice things about GraphQL over the other ones is that the client specifies which properties they want to get back from the server. So on the server, you have a complete list of every property that every single client is asking for. So you know whether that deprecated property is still in use or not. It's quite computationally expensive, but then that's only money to AWS. You can find out, that's the key thing. And if you can find it out, you can detect that there's only one client left using that deprecated property. So you think, yeah, we can delete it. And then you look them up and discover they're your major client. So you can't delete it quite yet, but you can open a conversation if you're big enough and they are big enough, and we can do things. You can't do that with REST. You send a representation down the wire, you can't ever know what the client is doing with that data. Same with RPC. Send a function call sends some data back. You have no idea how the client is using that data. So that is definitely something that GraphQL is better at in terms of versioning. A little bit about design considerations. This stuff is hard. This stuff really is difficult. It is very, very hard to design a good API. It's very, very hard to design a good application. You may have noticed. Main problems are you need to balance the developer experience of your API with your internal app capabilities, with what your project and product managers want you to build for a budget that's too small. Very, very loosely. It's really, really easy, particularly with GraphQL, to create a query that DDoSes yourself due to the nature of the server having the control. This stuff is always hard. With REST, you are balancing the amount of data you are sending down the wire, which is a cost in terms of network transfer, in terms of time for that API call to happen, versus how many pieces of that set of information the the average use case will need. So if I ask for a user object and send back all 30 pieces of information, but 99% of my clients use 3 of them, I'm being incredibly inefficient in that RESTful API design. Equally, if I'm sending back, say, 10 pieces of information, but most of my clients are having to make a second call to get another 5 pieces of information, again, I'm being inefficient. So there's a definite balancing act here with RESTful APIs on how much data you send back in each request. It's not easy. It's your choice. So in REST, the structure of the request object is defined by the server. In GraphQL, it's defined by the client. This is really important. It's a big part of GraphQL. We are eliminating round trips with GraphQL, avoiding multiple requests to get sub-information. Is that a big pain point? If it is a really big pain point, then GraphQL might be a really good choice for your particular application. It's quite interesting. GraphQL REST is a little bit like comparing an SQL database with a NoSQL database or document database. You can do pretty much everything in either one. Their strengths and weaknesses. I like them all. I literally don't care which API we pick. I care that you get a good one. That I really do care about. I want a well-designed API more than anything else. I would far rather you wrote a really, really, really good GraphQL API than wrote a shitty RESTful one. Or an RPC one. If you can make me a really good RPC API that I can use with no problems, I'd far rather that than a GraphQL one that keeps breaking because of complexity and you can't handle it at the other end. Far rather that. Build your API well. Think about your developer experience. You need people to use this API. People use APIs that they understand and that help them get their job done quickly within the sprint. That is their main criteria. They don't care about pretty much anything else about your API other than how quickly they get their work done. This is why nobody likes PayPal's API or eBay's, and why we all like Stripe. Stripe is dead easy to integrate. They've put a lot of effort into this. Correctness matters. Number of ways. In RPC, we care that the function works and does what it says on the tin. So if you've got a function, it should do exactly what it says it should do. If it's REST, it must operate the way HTTP operates. If you create a RESTful API where I do a GET request and it deletes some data off your server, then we have done something wrong. We've broken the compact. I have seen this. It's horrible. A lot of people found this out when they Google changed the way their prefetch worked on their search bot once. Status codes matter if you're doing RESTful APIs. Get them right. It matters a lot with RESTful APIs. It matters whether you're using a 200 or 400 or 500 for what you're doing. Media types matter on RESTful APIs. Hypermedia matters on RESTful APIs. There's a lot of things there, but getting them right will make your developers' lives much easier. With GraphQL, you have to think in terms of relationships. The clue is in the name. Graph. Think about the way your developers are going to be accessing the data you hold and design your GraphQL API to fit the way they will be using it. Now, I've got to admit, my sample size of integrated against GraphQLs is remarkably small. I've only integrated about 6 or 7 so far. And in 4 or so of those, the design has been terrible. It's not easy in GraphQL to get it right. And what's most interesting is that people seem to expose their database as a GraphQL API and call it done. Now, I've got some sympathy for this because you can drop a tool in and it does most of that work for you. And we did the same thing with RESTful APIs 10 years ago. It was really, really common 10 years ago for a RESTful API to basically expose the structure of the database. Don't do this. It's really, really bad because the way your database is designed and the way you have built your database schema is built around the operations that you are doing internally, the way you think about your app. When a developer is using an API, they are probably using it in order to ask questions about your data in a way that you didn't think about. Because otherwise you would have put it on the dashboard for them, and they wouldn't need the API in the first place. And this is really, really common, and I try not to rant too much about this, but one of the software systems I've been using recently is all about SOC 2 compliance, and their data is organized in such a way that the query I wanted to get out could not be done with their GraphQL API without making 45 calls to get a list of 3 computers. I could not believe it. And it's entirely down to the fact that I was asking a question that their API, their database design hadn't thought anyone would ask that question of. And that's not unusual. Your database design is different from your API design. Your API design is there to allow flexibility for your integrators to ask questions. Talk about GraphQL, think about how you're going to allow nesting. Now, one of the cool things about GraphQL is that the client can pick what they want to nest. So we can pick all the books from the author in the same query. But guess what I can also do? I can select an author, I can select all the books from that author, and then for each book I can ask for the author again, and then I can ask for all the books from that author again. And then I could do it again, as many times as I like. Because GraphQL will let me do that, because there's a relationship between the author and the book. Imagine what happens to your database server when I go and ask for that query. That's bad. We call that complexity. I say we. The GraphQL community calls that the complexity of the query. And it's not uncommon to put a limit on the complexity of the query in order not to actually cause your system to fall over. So you should definitely put that in place if you're building a GraphQL API, but you should put it at a level that makes the most sense for the types of queries you're expecting. And then your GraphQL API will hum nicely and not fall over when people do stupid things. They don't do it intentionally, well, most of the time. You just don't realize. You think, oh, I can link this to this to this to this to this, and suddenly it's taking 45 minutes to get a reply back because it's too complicated. There's not absolute specifications in terms of GraphQL on how you name things like pagination, the way which properties you use for pagination, etc. There's not actual standards yet, but there is a project within the GraphQL ecosystem called Relay, and something called Global Object Identification within the GraphQL ecosystem. Both of these are awesome. If you're building a GraphQL API, Global Object Identification is one of my most favorite things ever. And if you follow the Relay project's pagination properties, then you're doing it the way that most of the ecosystem is doing it, which will help your developers. In all these cases, naming things is hard. I might have commented on this before. It's a truism. We laugh about it because it's true. It's really, really difficult to name things. So follow the conventions of the API system you're building and be consistent about it. So if you're doing GraphQL, singular and plural matters because people have expectations about what that means. If you're doing a Restful API, be consistent. If your collection names are always singular, don't put one endpoint in that is plural because you will confuse everyone. Take the time to think about this. Think about your collections, think about your scalars, think about the data types for everything you're sending down the wire, because that will help with versioning, and most importantly, not breaking backwards compatibility. And those are all general. It doesn't matter which API you're doing for that, but they will make or break your API even more than whether you've chosen GraphQL or whether you've chosen REST. Errors. In an ideal world, none of your integrators will ever see an error from your API. In the real world, every one of your integrators will see an error from your API. Treat them as first-class citizens because they will get seen. Most importantly, remember that humans are going to be reading your error messages, and machines will read the successful messages, as a general rule. Errors are the ones that turn up in logs. Errors are the ones that at 3 AM in the morning, some poor developer is pulling over to work out what's gone wrong and why they're down. Think about that. Try not to be the one that makes their life hard. So those obvious things your errors should handle is you should provide the correct information. So if you're doing REST, you should provide the correct status code. So this is a 503 in this example. Service is unavailable. You should provide information about what the error is, written in human-readable format for that poor developer at 3 AM in the morning. Could not authorize user. That's pretty clear. I know what's going wrong. Detail. Auth service is down for maintenance. Oh, whatever. At least we know what's going on. Also provide a machine-readable, immutable, never changes code. So this one is auth service underscore unavailable. Because we will want to do metrics on this. We will want to have automation built into our systems, and don't make as developer have the string match. That's horrible. GraphQL, same basic things happen, but note, you will always get 200 back unless the thing is actually down. That's really, really common because it's more RPC-like in that sense. You will tend to see cryptic error messages from the GraphQL thing you've stuck in front of your application. If you can override those and put nice ones in, please do so, because it's horrible from the integrator's point of view. You'll see a top-level errors key for exceptional scenarios. So if you've got rate limiting, for instance, you should expect to have a top-level error key for that. To the complexity issue, that will probably be a top-level errors key. Syntax errors, things like that. If you've got a domain error on a GraphQL database, API, then the domain error should be within the schema itself. Because if you think about it, I'm retrieving multiple levels of objects. And if there's a problem with the third or fourth level down, I should have still received the first two levels. So I'll get back my authors, but I might not get back my list of books. So the error for why I couldn't get the books back should be within the books section of the result. You have to go looking for it. Related to that, I mentioned that you have to ask for whatever properties you want back. Make sure you request the errors one, because otherwise it won't tell you. You'll just get back an empty collection. That's really common. I say really common. Again, in my sample size of 6 or 7, at least 4 did that. I've seen it handled within GraphQL is to use a union of 2 different types. So the example I've put up here is the create user result, which has got a user created type and a user creation errors type, and it's a union of them, which means that you'll get one or the other back. So it's quite easy to request that way. That's quite a good pattern. I'm seeing that quite a lot in GraphQL. So look at doing things like that to make it easier for your users to see the errors. Documentation, same basic thing. You need an API reference. That's built into GraphQL. For REST, use the Open API specification. Don't use anything else. We've standardized on that now. Just use the Open API spec. It makes life so much easier because you get tooling. I say it's built into GraphQL already, so that makes GraphQL much easier. Explorers are quite easy to find. Right, some tutorials. API references the what. The tutorials are the how and the why. Don't leave them out. Particularly how to auth. Lots and lots of detail, please, about how to do authentication if your system is non-standard. Particularly if your system is non-standard. Make life easier for your developers. You want some inspiration? Look at Stripe or look at GitHub. They're both good. Here's GitHub's GraphQL tutorial section. So you've got a nice start here at the top. You've got information, and you've got what's new on the left. This is a Restful one. Nice start here at the top. Information, what's new on the left, on the right, sorry. This bit is the same regardless of what API you're building. Developers have the same things they need to learn to use an API. Your documentation needs to be good regardless of your choice of API. And that's it. So hopefully you've learned a little bit about differences between RPC, GraphQL, and RESTful APIs. I've suggested that you should pick the best one for what you're trying to do. And I've included the idea that you can just pick the one you like. If you like it, go for it. If your team is all on board for building a new GraphQL API, do that rather than make them write a SOAP one. If you're not sure, pick REST. You won't go wrong. You will have a lot of developers who understand how it works. You will have a lot of documentation about how it works and how to build for it. You'll probably run into fewer edge cases that you don't know about because it's older and it's not stupid. GraphQL, slightly more recent, so there is less corpus of information about it. But if you know you want to do a GraphQL just because you like it, go for it. You will make a better API that way. Arnold Lauret wrote this: if you suck at providing the REST API, you'll suck at providing the GraphQL API. It works the other way around too. The API doesn't actually matter. The actual structure doesn't matter. You can make a terrible API regardless of which one you've picked. And you can make a kick-ass one regardless of which one you pick. But you have to be intentional about it. An observation I've noticed is that the second time you write an API, you make a better one than the first time. So you'll tend to see that if you wrote a really, really bad RESTful one and then write a GraphQL one, your GraphQL one will be better because you've learned about how to build APIs. It wasn't the GraphQL, it was the experience you gained. You will gain much more and make better APIs by getting experience in writing APIs. And I'm done. Thank you very much. And I believe that's excellent timing for room change. So if you have a question for me, please come and talk to me separately.
So, thank you. I'd like to welcome you I'd like to welcome you all. God damn it. Great start. So, my talk is about your first PHP extension. And no, the chemist is not a typo. It's actually stolen from the title of a book by Robert Boyle. It's about alchemy for the skeptical chemist. And this is like the turning point of where historical experimenting turned into proper science. And it will become relevant in this talk, but I won't bore you, promise. So, and now I have to turn on my clicker. And yeah, my name is Christian. I'm resident madman at Shopware. I'm the one who tries all the weird stuff, like writing PHP extensions in Rust. You can find me on the Bird site as well as on Mastodon. And today what I want to show you is how we can capture lightning. So what you see here is a painting of the discovery of phosphorus. This was done by Henning Brandt in Hamburg around 1669. And what you can see here is a guy that boiled down 5,000 liters of urine to arrive at a flask that is glowing and bursts into flames due to all the toxic chemicals he managed to release. That's also why he looks so surprised. And the thing is that alchemy can be dangerous, and we want to do it in a safer way, but we still have the same general idea. We still want to achieve the same goals, because we want to pierce like the crust of our normal environment and figure out how nature works. And we want to do this today with Rust. Sorry, not with Rust. We want to pierce PHP and then discover the rules of PHP in Rust. So, but to discover new things, we need a laboratory for that. And in the olden days, they might have looked like this. It's pretty cramped, it's cluttered, nobody uses namespaces, everything is on one heap, and the type system is pretty rudimentary. Still, you can get a lot of good science out of using the old style like this. But nowadays, we have nice laboratories with things like fume hoods, so you don't accidentally gas yourself. And the same way, I want to show you, first of all, a reproducible build system that uses the Nix ecosystem to declaratively set up a development environment, and then use that development environment to actually run and compile the Rust code. So, for that we are using devenv. Devenv is a tool that's quite young. It's you should definitely look at it because it's very useful for PHP projects in and of themselves. And it is built on a very mature technology, which is the Nix build system, which has been around for almost 20 years now. So, in this devenv file, we will configure our development environment. This is a Nix expression, so the content of our devenv.nix, and we will start with the quite simple and obvious. So we want Rust, so we enable Rust. This gives you all the tools you need to use Rust. It will give you Cargo, the package manager, basically the equivalent of Composer in Rustland. It also gives you rustc. Rustc is the compiler and the actual executable, which is kind of equivalent to PHP. And if you heard this before, you were at Nunu's talk yesterday, because he made the same metaphor for it. But this also installs things like the Rust language server. And the Rust language server is like an IDE framework already built into the language and into Cargo. And while a separate project, it is like the main way for editors to understand your Rust code. So you can just install VS Code or Vim or whatever additionally, and then your editor can use the Rust language server to get inspection information, auto completion, things like that. And all the configuration for that is already done by enabling the Rust language. Next up, we want PHP. So to use PHP, we use quite a bigger expression. This is the whole expression that defines PHP. Well, not quite. There's a little caveat I'm going to talk about soon. First of all, obviously we enable PHP. But after we enable PHP, we need to define what kind of PHP we want to use. This is the isolation I talked about previously. So devenv allows you to specify specific packages and specific versions and specific setups of PHP. And in this case, we are using a wrapper, it's called, so PHP unwrapped build environment. So we are calling the function build environment to create our development setup for PHP. What this does is it leaves the all the PHP source code intact, so you can still link against it, so you still have the PHP headers in your path and things like that. Also, what we then do is we will add the extensions. So you can define an arbitrary set of extensions from all the possible extensions. But for this example, I just need readline because I developed this together with a REPL, and for the REPL you need the readline extension. Also, you can add custom PHP configuration. This will end up in your conf files, in your ini files. And yeah, I'm just setting the memory limit to -1 because who doesn't do it? So then we can actually start developing our Rust program. So we made our nice little folder, and we can call cargo init, which will initialize a Rust project in the folder where we currently are. That's why there's the dot. But we also pass it the parameter lib, because the PHP extension system works by including a shared library. So like a binary that has no main function. And to create something like this, we need to tell cargo about it, and that's why we call it with a --lib, which means it creates a library with a lib.rs file instead of a main.rs file. But that is in theory enough to get started developing an arbitrary library. The only issue is if we would now start and try to develop a PHP extension, we will end up with quite a lot of pain, because we have to do all the interfacing with the PHP engine ourselves. We have to write our own abstractions that take the basic C code and the header files and all the API that the engine provides to Rust equivalents. And apart from the fact that something like this would definitely not fit in a 45-minute talk, there's people that have already done this for us. So let's have other people experience the pain, and we just come in afterwards, nice, and have fun developing an extension. And for that, we are using the crate. So crate is like a package in Composer or a library in general languages. We add our extension PHP RS crate, and this will provide us with an API to nicely and natively for Rust interact with PHP engine. So let's have a look at the actual code in our extension. Once you initialize a library, you will only get a few files, so cargo configuration, things like that. I'm leaving that out for time's sake, but also because, frankly, you can look it up, and I will provide you links for it at the end where you can look it up. But you will also create a lib.rs, which is the entry point for our library. And how do you start any good project? Of course, with a hello world function. So now we're going through the actual Rust code. And while this isn't a general introduction to Rust, I will go with you through all of my slides, and I will show you what every line of this code means. So, first of all, similar to PHP, we need to include all the files that aren't part of our project yet. We need to include all the files which contain things we want to use in our file. For that, we have the use keyword, and what I include is everything in the prelude namespace or the prelude subcrate of the PHP RS crate. The asterisk just means import everything, because the prelude one includes all the generally useful and necessary items to start developing a PHP extension. And also, just for your information, I will skip the includes for the rest of the slides. This is just you get a feeling for it, that it's quite easy to get started, but it would just clutter the slides afterwards. So, our first function, hello world. I mean, I guess you're all familiar with functions, I hope, but I will still explain how they look in Rust. So, as you can see, the first keyword here means pub. Pub means it's public function. Because we are talking about a shared library, Rust can decide to either add functions in that expose functions through that shared library or not. And the pub keyword means it will expose this function in the shared library. Fn is just a word to say, hey, here comes a function. Hello world is our name. I guess you figured that out. And then we have a parameter called name, which will take our name for the person we want to greet. And now comes the interesting part, because the parameter has a second part. And this second part is called a reference to a string. Now, Rust has a concept of own types, so values that represent their data, but also references, which are variables that represent just a pointer to a value. This is quite an important distinction in machine close languages, so in systems programming languages, and this allows you to be way more explicit with how your memory is laid out and where everything is. So you don't need to copy data all the time. And then we get the arrow, and the arrow just means everything after that is our return type. And in this case, our return type is string. Now you might ask, why is name a string when it's a reference and like totally weird? And why does string look like a normal class or a struct? And the thing is that the reference to a string is like a historic thing in Rust, because it also implies some other things. But honestly, it's just a bit of an inconsistency, which I guess as PHP developers we're all too familiar with. And that means this is a reference to a string, and you can't mutate the string, and you don't have to copy the data. Whereas this means what this function returns are the actual bytes of the text that you return, of the string. Also, that's a little simplification. It's a bit more complicated under the hood, but it will suffice to understand the rest. So what does our function do? Our function prints hello name. This is called a macro. That's why there's an exclamation point. And what this means is this can kind of break the normal language rules to like automatically construct something. And you give it a formatting string, so kind of like printf, and the placeholder will be replaced by the variable. And another thing that you might notice is no semicolon at the end. This is also like a special marker in Rust, because this means that the last statement in a function without a semicolon will return. So you can keep the return keyword away and just say, hey, my last statement without a semicolon. So the value of the evaluated function here becomes whatever is the result of the evaluation here. Now that is all fine and good, but how do we get it in PHP? And I guess you spotted it from the first moment I talked about this slide, which is this attribute. This attribute means that this function will be exposed in a PHP conformal way. So for a C function or for a machine function to be callable by PHP, it needs to conform to certain to a certain schema, to certain requirements. And normally you would have to write all that glue code yourself. But the XPHP crate allows you to just annotate an attribute to a function, and then during the compilation, this crate will do all the necessary steps to generate a proper wrapper to take a PHP string, take a reference to its contents, and then use the returned value of string to create a new PHP string, register its contents with the PHP engine, and return it to like userland again. That's not all, because in general, when you are installing an extension, PHP needs to know what the extension does, like what it's called, what the functions are, what classes are, things like that. And for that, there is a config function that you canonically like give it the right name, and PHP will call it. But in our Rust example, we can just write our own configuration function, again, just a public function. It takes a configuration builder, and then you can modify the configuration builder with things like different names, different class entries, etc., and return the module builder then, so that the PHP extension Rust crate will create a proper extension from that. Then we just annotate it with the PHP module attribute so that the compilation step knows which function to evaluate for that. Okay, that was quite a sprint, and I've promised you we're going to capture lightning. So, you might ask, what kind of lightning? Well, we're going to capture Lightning CSS. Who here heard of Lightning CSS? Ooh, at least a few people. So, for everybody else, Lightning CSS is a CSS parser, transformer, bundler, and minifier for the Parcel project, and is implemented as a Rust crate, but also then exposed as an NPM library and a binary. And this allows you to take your raw CSS and bundle it and minify it and also apply it to different browser targets, all very quickly and in one go. And we at Shopware have a theme system. So what this means is people can customize their shops by uploading plugins that contain themes, and these themes need to be compiled on the fly. And for that, we also have a CSS prefixer and minifier and bundler and things like that, but they are currently implemented in PHP. And now I figured it would be kind of fun if we could use a Rust library directly out of PHP. All right, but now that we know what our Lightning is, we need to somehow get it. For this, we can just call cargo at Lightning CSS. Lightning CSS is just another crate, like a composer package. You can require it and then add it to your project. But how is this then going to look in practice? So we've got quite a bigger function now, although it is still conceptually pretty close to our Hello World function. To start with, let's again go over the function header. We have a function called transform. This will transform our CSS. No surprises there. You give it our style. So our CSS, again, as an immutable reference to a string, because CSS, as you all know, is a text format. You just give it that. Now here comes the first really new part. We no longer return a string, but we return a result of string. And a result we'll get back to later, but it symbolizes a fallible operation. So it represents a function call that can potentially error out, create an exception, etc. The next thing then is we need to actually get our CSS into like Lightning CSS. And Lightning CSS for that provides a style sheet namespace / struct. And this struct then can be created from like a ball of CSS and some parser options to configure how it's going to parse that CSS. But in this case, I'm just going to take the simple route and just call default, because, I mean, what am I? Reading documentation? Like, no. Then we actually come to the important bit, which is we want to minify it. Again, with the default options, that's good enough. We'll get to those later. And then, last but not least, we need to tell PHP again, like how our CSS looks. And for that, we are returning a result. So again, a wrapper type, a generic type, and our result can have two different states, so OK and error. This is the OK return, so this means our computation did not fail, it succeeded. And we are going to print our CSS to a string, but then also allow it to minify. So for once, I'm not using the defaults untouched. I at least specify that I want it to be minified. And so we pass it the config, we get back our result, and then we access the code field of that result and return it. So we've got a string of our minified CSS. So let's get back to our result. As I said, it's a fallible operation. So what does fallible mean in our context for our transform function? It means that it can crash, or not crash, but it can stop working if, for example, the style sheet encounters a parser error. So, for example, if the CSS is malformed, or if the CSS is malformed, or maybe there's like an error in the read process and you don't have a full string, things like that. But now we are hitting our first roadblock with this map error function, because the result type I've inherited from a library or a crate called anyhow, which makes our our result handling a whole lot easier. And the thing is that when the style sheet parsing crashes, it wants to return a very speaking and a very helpful error. For that, it references the part of the style sheet that produced the error. So the problem is that when parse has a problem and returns an error, that error still contains a reference to the string. And we can't just return something that contains a reference to something wholly else that we kind of did in the middle of it, because then Rust cannot track its lifetime. It does not know when to clear up the memory. And for that, I'm doing a very quick and dirty way. I'm creating a new error from my old one, which is just a string representation of the old one. So basically, I'm just saying, hey, print me the error description, put it in a new box called error, and then we return that. And this returning of the error is also what the question marks are for. You may have noticed them before, but these are the syntactic sugar that makes Rust error handling quite comfortable, even though Rust doesn't have exceptions. So in PHP, you can just throw an exception which will automatically unravel the whole function stack until the point comes where it is either at the top level or it is catched by some catch block before. In Rust, you don't have the concept of an exception, at least not properly. You have panics and stuff like that, but let's not get into that. And the question marks are a shortcut for if you encounter an error at any of these points, you will just return the error value as the result instead of the actual OK value. And this also means that every time at these question marks, below them, we can be sure that whatever the function returned was OK and is unpacked. So style sheet parse returns a result CSS. But here we have a plain CSS because we could safely unwrap it after the question mark, because if it would have failed, it would have already returned the error. Okay, now, there's more ways to capture lightning. And this is why I totally forgot that I highlighted OK. So, sorry for that. Now, there are other ways to capture lightning with another angry element. I think we've talked quite a bit about how we build a simple function to minify our CSS. But we started with alchemy. And I want to know, just segue a bit away and show you how modern scientists can capture lightning with oxygen. And oh my God, this didn't work at all. So you see this angry red glow down here. And this angry red glow is how modern scientists create lightning in a bottle, because they just take two very reactive chemicals, so oxygen, which is dissolved in here, and pure chlorine, which is incredibly reactive, and blubber it through there till it starts to glow. And what this glow means is that the oxygen is very angry, because the chlorine just rips off electrons and leaves it in a state it normally is not available in. And so it returns a red glow. And so I want to show you now how we can capture lightning in a more modern way, because at the end of the day, we are at a serious developer conference, and as we heard in the keynote today, we want to improve our quality of life. So I'm now going to show you how we do it the object-oriented way. And for that, we obviously need an object to present as. And for that, we create a CSS transformer. Now, the thing at the bottom is the struct definition. So structs are look in some ways similar to PHP classes, but they are not quite. The difference is that a struct is has a defined memory layout and is only about the data. So structs only contain data, functionalities, method, things like that are only added in later as a separate thing, kind of. So we have our CSS transformer and we want to configure it. So in Lightning CSS, you can configure for which browser versions you want your CSS packed. And for that, we give it the browsers list. The browsers list is a type provided by Lightning CSS, and it's a struct containing all the versions of the browsers as integers, which will bite us later, as I'm going to show you. And we have a minify value because maybe for debugging purposes, you don't want to have your CSS minified. Still, we have a struct, but it's not in PHP. That's why we have the PHP class annotation. As you can see, you can give annotations parameters. And in this case, we can give our class a name, or sorry, our struct a name for the PHP class. And the great thing is that namespaces are just part of the string. So you don't have to create like a separate namespace object or something like this. You can just add in the backslashes, and we have our Flash CSS transformer, and we can use it from PHP in the future. So, but we don't have much use for a struct without any kind of interactivity. And for that, we are going to implement some methods. This is done in Rust through an implementation block, an impl block. And we implement the behavior of the CSS transformer. This is what I mean by having structs as a separate thing. So you have data on the one hand, and you have the general behaviors of it separately. This also comes into play with things like the type system, the trait system, stuff like that, but let's not get into it yet. So we want one method and one static construction function. The thing that makes a method in Rust is because it is passed a self parameter. Again, this might be familiar if you've seen yesterday's talk, but let me explain it again. The self parameter is like a magic variable name. So every time in an impl block, Rust encounters a self variable. It knows that this variable references the actual instance of the struct you are calling it with. This is the equivalent of PHP this. Except in Rust, you can also specify what kind of reference you want. So either an immutable reference like this, but you can also have mutable references, or quite elegantly, you can also like take ownership of the value itself. So you can build a function after which you have no longer access to the object on which you called the function, sorry, the method. And this is especially useful for things like state machines. So you can basically eat up a state and return a different state, and they are on a type system level split up from each other and irrepresentable as wrong states. But let's not get too deep into that, because we also have a constructor. Oh, sorry, we have a PHP implementation, as I already said. We have a PHP constructor, and this is also just magic done by the impl annotation. It detects that you have a function called construct, like in PHP, and this will return a struct of type self. So in this case, self is like a magic struct definition, and it always refers to the struct up top in the impl block. Now, let's have a look inside the constructor. It's very complicated. It instantiates a struct. It uses the browser's default list, sets minify to true, and that's it. That's the whole of the construct function, and the PHP crate will do everything to like wrap it up, register a proper class name, and also create a magic function to create the PHP class with the data returned by this Rust function. Now, we also have a transform method again, and in this case, we want to actually use the configuration that we store inside of the class that we created, inside of the struct. And for that, we are going to reference the self variable again. And let me show you how you can access the data inside of a struct. And in this case, we can just reference self.minify. Minify is a bool, which means that Rust automatically knows what to do if you want to copy it. It's a bool, you just have to like copy a byte, and then you can take the byte out of self.minify and put it into our config for our Lightning CSS. The parts I've left out are just the same as in the function version, so in the non-OOP version, and these are just the changes that we made to that. The next thing is, which is a bit more complicated, is browsers is a more complicated type. It's a struct. And so Rust does not automatically know how it can like easily replicate the value. It needs to do some memory cloning. So it needs to iterate through some bytes and fill other bytes with that content. And for that, we call clone. Now, why do we even have to do that? That is because the minify options wants the target's value, not a reference to a target's value. It wants the value itself. And so we have to clone the value because we only have a reference to ourselves. And unlike in JavaScript, you cannot scope the mutability only to the upper parts, but it will automatically move down through all the structs. And then again, we wrap it in sum, which is like a nullable type. So in PHP, we can type in like my class name null. And in Rust, the equivalent would be to define it as optional. And optional values can have sum as a value, which means there is actually something. The alternative would be none, which means there's nothing. Okay, so how does this look in practice? Like this. This is now the PHP code we can create with that. We can instantiate a new transformer, which I've misspelled, great. And this this object now has the ability to transform our CSS according to the configuration we created in Rust. And then it also returns the minified CSS. As you can see, there's just one little problem. Our configuration is still in Rust. We can't access it from PHP. And for that, wouldn't it be great if we could just define the configuration on creation of the transformer? And for that, we have to modify the constructor again. So this time, our constructor actually gets a parameter. This parameter is one of those optionals I've talked to before. So this means we can leave it out if we want the default config, but we can also provide one. And the configuration is provided as a hash table. And here is the first time where we actually interact ourselves with PHP types. So this is exactly what I wanted to talk about, where we can interface with the PHP engine itself, and we have to figure out how to access values there. So a Zend hash table, or a reference to a Zend hash table, represents arrays in PHP. As you all know, arrays can be maps or like normal lists, and under the hood they are all stored as hash tables with some extra steps. Then we also need to tell our PHP crate that the first parameter is optional, so it is also represented in PHP as optional, so you can leave it out. So what do we do now with the configuration? We have our base configuration, which is the result of our old constructor. So just the defaults, minify, true, easy. But now, because config is optional, we have to be sure that there's actually a hash table given as a parameter when we want to access it. And for that, we use unpacking. Unpacking might be familiar to you from languages like JavaScript. And what it means is like applying the constructor in reverse. So a constructor for an optional value is sum with some value in it. But this is on the left side of a let. So let is an assignment, like a plain equal sign in PHP. And our config value is the option. And what this thing here does is it takes the config option and it tries to match it to this block. So if the config is sum, it will assign whatever is in this sum value to the variable config hash table. And now here's a feature that was only recently introduced in Rust. If this fails, we can have an else block. So if config is none, it cannot match this let block here, but then it will run this else block. And in this else block, we just return OK with the base transformer configuration. So what this means is, if you don't give it any configuration, you still have the same behavior. It will return the base one. Now we have to actually look into our config and apply it to Lightning CSS. For that, we have a for loop. So what this for loop does is it creates an iterator from the hash table, which is also a nice feature provided by our extension crate. And then Rust automatically knows how to use an iterator, a bit like an interface, in a for loop. And this for loop will then iterate over the contents of the iterator, which are triples. This is again one of those complications with with PHP hash tables, is PHP hash tables are not purely based on key value pairs, but they also store the index so that you can also use them as a list. And what this does is again like unpacking structural matching. The iterator returns one triple after the other, and each of these triples will be then unpacked into an index, a key, and a value. And we prefix index with underscore because we don't care about numerical indices in our configuration. Now, because the key is optional in PHP, again, We also have to match it against our optional type because, well, you can just insert a numeric key. And in this case, we wouldn't have a string key. So we match it, and again, we have an else block, but in this else block, we do the very not so proper way of just continuing with the loop, just whatever. It's data we didn't expect, but don't care. The error messages will come later. So with that key, we can then try and apply the configuration from our hash table to our config struct. And for that, we use a match block, which is not equivalent, but kind of similar to a PHP switch case. And this will, and also the PHP case thing where you actually return something. But it's similar to that. The idea is that you provided a value, and then you have a list of cases against which to match, and then it will execute the block that matches. So here we have our key, which is a string. We get it as a reference, because here's the next thing. These hard-coded strings in Rust, they are written as values in the library itself. So in the shared library file, there's a place for all the hard-coded strings, and this thing will evaluate just to a reference. And so we need to take a reference up there as well. With this reference then, we can match it, and if we specify a minify option, we actually care about the value. Now, the value is always there, because again, only the key is optional. And the value is of type Z value. And Z value means Zend value, which is how the PHP engine internally represents all the values and allows a strongly typed language like C to represent many different types of data, like strings, ints, floats, etc. And in our case, we want our Z value as a bool. Now the thing is, this cannot be like a Rust native cast, because the information what is contained in here is only available in runtime from the PHP engine. And so bool can also return a result, an error type. Or I think an option type. I don't think it actually throws an error. And what we use here is unwrap or default. This is also, again, like the easy way out to fit it all on a slide. In a real program, you would tell the user that, hey, you should pass a bool as a minify flag, not like any random value and then just ignore it. What this means is, if the Z value contains a bool, it's okay. It will just unwrap the optional type from it and set base minify to this bool. In all other cases, it will ignore whatever went wrong and just return the default value for a bool, which is false. Again, kind of a dirty way, but at least it fits on a slide. So, and now we get to our last block, which is the actual targets thing. And here, we have a list of targets, so browsers and their versions as a string in the format of a semantic versioning. And for that, we first of all have to figure again out if our Z value, well, is actually a PHP array. And we can do that by just calling the array function and then checking like, yeah, okay, if this result is if this result is okay, everything is fine, it's great. If it's not error, we just tell the user like, hey, targets must be an array, you made a mistake there. This one fit on the slide. And then we again have the same pattern of matching a sum to get it out. I'm just trying to be very explicit here. You could write it way more terse, but then it would be harder to understand. I kind of want to reinforce the pattern. So again, an if let means, hey, if this works, just do it. If it doesn't work, then we could provide an else block here, but in this case, I don't actually want to do anything, so just let it run through. And then we get our Chrome version. Now the thing is how the browser versions are specified in Lightning CSS. It is fields per browser in a struct. This is not very dynamic, which is why we have to unpack it in a very verbose way. So we have our map, which is a Zend hash value again, hash table, sorry. And then we just call the get function with Chrome. This is like a normal key lookup in a PHP array, like in PHP. And then we can map over our result type. So this can also return none, because obviously there's no guarantee that this key is in our hash table. But if this is not none, so if it were none, this is the if, and we just run off. But if this is some and contains an actual value, we want that value as a string. So in this case, we have the z-value string thing, and this is again the way in which Rust separates data from functionality. So the impl block for the z-val type has a function called string, and this function exists in the whole namespace of Rust, and you can just reference this function and then afterwards apply it to the data, so you don't have to know the struct in advance. And so once we have the semantic versioning string, we do some pure Rust code to take that string, explode it apart, and then bit shift it into an uint32, which is very fun because once Chrome hits version 256, this will break, but then again, that's not my problem, and Lightning CSS is still in alpha. Okay, so how does this look in practice? We can now define our configuration on the construction of our object, of our transformer object. We can then call the transform function, and we then get our minified CSS. So that's the technical part. Let's just wrap it up. As you can see here, these were people that were doing science back then. And we kind of want to do something similar. I hope I gave you all a seed to think about that. What we want is to learn about the nature of our environment. We want to know the nature of our work. Like, how does PHP work? We all do it in a way. And the other thing is that also, is kind of the standard thing of scientists is, no matter how exotic and toxic and horrible the thing is under the hood, you shouldn't fear it. You should have respect for it, definitely. Like, I'm not going out here and telling everyone, just implement everything from now on as an extension. That's obviously not a good idea. But I hope that now you're not thinking that's low-level stuff, this really ugly and horrible, but that you at least are curious how it works, and that if everything else fails, it is still an option. But there's also more concrete improvements there, because in all of development methodologies, I've stolen a bit from a philosophy of software design by John Ousterhout, which splits up development in tactical development and strategic development. And in the tactical sense, in the day-to-day writing of code, I think that knowing something like Rust, knowing different languages in general, will give you a better understanding of API design, because you are aware of requirements that aren't able to explicitly specify in PHP. For example, mutability, lifetimes, things like that. They are still important. There's just not a way to express them, and in some ways, they are managed by the engine. The other thing is the strategic programming. This is the more general kind, like designing systems, figuring the general gist of it out, building systems that are resilient and that do their job well. And in this thinking, what using crazy things like Rust PHP extensions is, it's just a new set of problems to solve. Things like, hey, you can't just assign that value, it has a different type. You can't just change a value. This is not mutable. Hey, these values are sync and async, and you can't share them across threads. Things like that. They make you design systems with that in mind. For example, from my personal experience, handling Go and dealing with all of its async problems really made it easier for me to think about synchronization in my SQL databases, because also databases have to somehow synchronize data access. But it is something you don't really think all that often about if you're just programming PHP in the same old way. And last but not least, I want to tell you that this does have some real-world applications. For example, cryptography. If you have a fancy new cryptographic algorithm to hash passwords or hide some files or whatever, this is a way to use it. You can expose cryptography software written in Rust, maybe also having stronger safety guarantees, to PHP through an extension. You can use it to encode things. So maybe your advantage over a competitor could be that you can handle encoding of videos, photos, etc. during a request and not afterwards, because this will then mean you have a synchronous API instead of an asynchronous one. And also something that is dear to my heart, Rust also has quite a few cool graph libraries, and so dealing with graph data is also one of those ways we can use. So, with that, I want to say to you, go on, experiment, and thank you.
Thank you very much, Christian. Does anyone have any questions they would like to ask? We've got 5 or so minutes left. Yeah, you want to?
How much of the underlying PHP engine, things like class entities and such, does the library expose to it? So we've seen zvals there. What other mechanisms does it expose at this point in time?
At this point in time, it also exposes things like class structs in this case, class entries. Also, I think you have a way to get, you get the global class table. Things like that are also exposed. But to be frank, I didn't use especially a lot of the class features yet. So that's most of what I can talk about. Yeah.
Any other questions? No, I think that's it. Thank you again, Christian.
Thank you.
And everyone, it's time for lunch.
And action is my thing on. Hello, everybody. It's lovely to see all of you. Nice full room. This is very different from speaking at PHP UK last year, because A, it was the first pretty much worldwide event that happened post-COVID, so there was like less numbers, and then I was speaking before the closing keynote, and a massive storm happened, and about 5 people turned up, and I was on the main stage up there. So now I get to speak to people. Thank you for coming. I'm Jim Second. Hello, everybody. Here is my things. I've just amended this because now I have the elephant thing. If you like what you hear, say, hey, Jim, I like what you hear. If you hate what you hear, because you might also do that, because I'm going to be very noisy, by the way. I'm sorry for the front row. I'm going to be very noisy and run around a lot. Yeah, if you hate what you hear, also tell me. But because I'm in a department called Developer Relations, I thrive on your feedback, whether it's good or bad. If it's bad, then it means that I can be less rubbish. So please tell me. For anyone that doesn't know, the PHP social Mastodon account is run by Ben Ramsey, I think. And there's quite a lot of people on there. It's a great way of, it's less of the noise of whatever's happening with that right now. And you get, I really like it. So there's a lot of people that's been surprisingly more sort of popular thing. If you're on LinkedIn, because that does actually work, then you can check me out there. And then there's my, don't go to that, because you'll just see unfinished side projects everywhere. Right, I am a senior developer advocate, which sounds very posh. It basically is I'm a PHP developer at Vonage. If you haven't said hello at the booth, come and say hello at the booth. We've got one elephant left, limited edition elephant. Come and see us at the booth, and you can sign up. And before the closing keynotes, we will give it away. There's also a coupon code if you want to check out what we do, which is communications APIs, so sending SMS, sending WhatsApp, two-factor authentication, video integrations, things like that. Come and check it out. You can also reclaim the coupon code there, and you can get 10 euros credit for your account. So, let's go. If my clicker works. What I like to do is do a sort of an outline of what, because this talk is, I imagine everyone's reading and going, what's he going on about? What's this going to be about? So I'll just give a quick sort of outline. What is performance-driven development? Why should we be doing it? And how should we be doing it? That's the sort of the takeaway thing, right? Not sure if I've thought this through properly. Hang on a minute, let me think. Okay. Oh no. Right. Okay, so you got the question, right. What's performance-driven development, Jim? Go to my no. I don't think I've thought this through very much, actually, because I'll be honest. No idea. Ladies and gentlemen, thank you very much for coming to my talk. I've been Jim Second, and any questions from the floor? I am told in when I did this talk in Austin, I didn't have an earpiece, so now I can actually do this. I'm told in my earpiece through our producer, just roll with it, okay? I'm told that there's Q&As from the online chat room. There's no online chat room, just nod. There's some questions from the chat room, okay? Well, whatever. Put them up then. What are they then? Okay, look, you seem troubled. What's on your mind, Jim? All right. Bit judgy. All right. Okay, I'll tell you, because you want to know, right? Otherwise, you haven't done it, or I could start answering it and people start leaving. I don't know. I'll tell you what's on my mind. I am bored of hearing these things. Number one, hands up in the room. You're all going to do it. Come on. Who's heard that? Come on. Don't be shy. There we go. Come on. And you can say this if you go on, I don't know, Reddit's Programmer Humor or something. It's like, lol, PHP doesn't scale or whatever. For anyone else, don't go, especially if you're a junior coming into the industry, don't go on Programmer Humor in Reddit. It's supposed to be funny. It's not funny, so it's not really doing its job unless you want to sound like an 11-year-old boy. But whatever, you can do if you want to. But everyone there is very, very sure of themselves, and they think they're very funny. And the thing is, You can say something like that, that's fine. It's just that, you can be wrong. But there's other things that I hear, like, I read an article from 2012, which is PHP, a fractal of bad design. If anyone wants to see this, it's a very long blog post that's very ranty and very boring, and you're like, I think you should be spending your time doing something more constructive. Most of the things in it that are wrong have been fixed, or you will never touch, ever. It's like that sort of, I'm going to interview with somewhere, and they're like, can you do an abstract syntax tree shaking thing? And you're like, no, I can't. But also, you want to give me some CSS and move this that way, so I'm never going to do this in my job. You know what I mean? So people bring that up. That's still brought up. It's amazing. This was this was said to me about 4 months ago, and they said the thing is that the only thing, because 75% of the web, whatever it is that they turn up, WordPress is the only thing that's actually relevant in the PHP community. I think, core people that run Symfony and Laravel that are here today probably might go, not sure about that. But I mean, like saying PHP doesn't scale. For anyone that doesn't know, Slack was actually written, the backend was written originally in PHP, and then I made a joke about it, and it went viral, and then some bloke just said, like, actually, I think you'll find it's now Python microservices. You're like, yes, but that wouldn't be very funny if I said that, would it? So, why would it? But it was built in PHP, that was the point. And now just go back into your corner. The thing is you can be, it's like Slack with that. I mean, it's fine, you could be wrong. You could be wrong about that as well. I don't know, if you want to look like an idiot, sure, 1 + 1 is 5, whatever, mate. Look, there's also other people doing this, and it comes down to PHP is old-fashioned and no one uses it anymore. So now we're going to do Rust and Go, and there's actually I hope there's no Rust stations in the house, because there's literally a conference about Rust happening right now, and it's the next one. So, sorry, everyone. Golang, well, actually, and Nuno's done a talk about Rust. It is actually good, but it's like it's the next big thing. So now we're going to use like Remix, because JavaScript moves at 6 billion miles an hour. And now, I use this thing, the monkey thing, I can use that because the person that purchased it then lost it in the blockchain and doesn't own the rights to it anymore. But do they own the rights to it anymore? Who knows? I don't know. If you want to spend your money on rubbish, go for it. Sausage language is the new thing. I'm bored of these things. And this is where we come into things like performance. So it's 2022. You can tell if I gave this talk last year. It's 2023, and I got the date wrong, which reminds me of someone having an argument with ChatGPT this morning about what year it was. Go and check it out on Twitter. It's really funny. This was on, like, I don't know, Core or something, and they're like, don't pick Laravel, pick Django, because apparently your investors judge you on your web framework that you use. It's fine, you can be wrong. You can be wrong if you want to be. It means you look like an idiot, but you can be wrong. Investors don't care, they care about products, not what's running on it. And is it fast? That's the tech decisions, they don't care. We need to get away from this. But we are getting away from it, because this is what I want to sort of instill in people that don't come from PHP land. You probably are, this is PHP UK, but it's this ancient opinion about PHP being this legacy thing that's old-fashioned or something. Things are changing in PHP 8's speed, and it's the JIT compiler. Now we have native fibers in there. We have open source. I didn't put Roadrunner in there. I probably should have done that. But things like Laravel Octane running on top of it. We have really super fast asynchronous stuff. It's React PHP, if you want a good example of sort of seeing that. It's a shame that Marcel couldn't actually make this this conference, but check out the ngrok thing that he wrote in PHP. It's in React, and it's amazing. We've got a new asynchronous framework called X framework. These are modern things that are coming in. The take-up of test-driven development. I know that it sounds like, it feels like not enough of us are doing TDD, otherwise people like Mark wouldn't be doing workshops to try and get people to do it, and Chris Hart just hasn't spent his entire life basically moaning at you to do it. But the thing is that it is being adopted. In my work every day in the last 3 jobs I've done, TDD has been there. It's becoming more commonplace. We're getting there. PHP Unit 10 came out recently, but also we have a new testing framework called Pest. Things are moving on. We've got the quality, our code quality tools in our pipeline are so good now. PHP Stan is ridiculous. It's magic. And SAM PHP as well. And these static analysis tools will just do things that make it almost semi-compiled when you write stuff, which is mad. the individual Laravel and I took these two because they're the two biggest, right? The ecosystems are growing. There are new developers coming into both of those ecosystems. We are growing as a language. Things like PHP CS and Slevo mats, when it comes to linting, are brilliant. They can be part of the pipeline. And talking of the pipeline, now we have GitHub Actions, GitHub CI, all these kind of stuff. Yeah, okay, they're not PHP things, but mixed with all of this, this is a very, very modern thing to tool and write software in. But where does performance come into this? And that's what I'll be digging into, because it can do, but there's also, we've got a bit of a sort of an issue about these things. Right, next question then. Sounds cooked up. All right. Can you give us a real life story as an example? Let me think. Am I prepared for this? Am I prepared for this, Jim? Yes, I think I probably can think of a story. Let's look at something like this. This unnamed thing here is a proprietary CRM that's like the heritage of the old stuff from like 2004, those kind of things. And I won't name it. It has, I won't say what underpins it because that forms part of this slide, but the thing is like, I worked at an agency, they're like, hey, everybody, ship us the thing, and it was a massive enterprise thing. Right, so number one, in this agency, we use this. So how is that designed to then extend off it because we're building a custom piece of software? And the answer is this. Hooks everywhere. No actual inversion of control, no kernel, just hooks, just hook into the thing whenever you want. Here is a hook, here is a hook. What about that plugin? Like, oh, well, I've overridden you, blah, blah, blah. Like, okay, so those are the hooks. And then the rest of the makeup of this elsewhere looks like this. So you've got MySQL in the back end, and then Solr to sort of, Apache Solr was put on top of it, but actually the way they wired this together was that it used Solr as the single source of truth instead of the database with a caching layer in the middle of it. So it was like, why isn't my thing working? And it's like, the cache and it goes in there and the Solr goes on there. And like, okay, well this isn't good. This is a bit of a mess. And then we've got these caching layers here and custom Redis instances plugged into it. And then for some reason we've chosen UI as the front end. If you've ever come across that, I'm sorry. It's absolutely appalling. I know that's shaming UI, but no one's used it anymore because it's so ridiculously complex. So like, right, we're gonna ship this to the client? What's going on? And the CRM's like, I think people are complaining about our software, so we need to do something. Right, okay. What are we gonna do to make this better? I think if we do something like this, it might make performance better, perhaps. Maybe if I go and get my crowbar, there we go, right. There's the crowbar, and oh, okay, right, that's gonna fix some of it. Okay, right, fine. So that's on top of the hooks, so we don't have the hooks anymore. Now we've got Symfony underpinning it in the event system, but then it turns out the event system also works with the hooks. So then you've got the hooks and Symfony, and like, right, so this is gonna make debugging fun. So like, when it comes to the caching layer with the database, we've still got problems. Like, how are we gonna do this? And so instead at the agency, we're like, okay, let's fix the problem then. Go and get my crowbar. Here it is. There we go. That was shipped to production in a multinational corporation that most of you will know. That was the solution. This is about performance-driven development. If we want to do performant code, and that's the solution, this sausage mess of spaghetti, we're not doing things right, are we? So, we've got to change things up. Go on, question then. Show me some bad code then, fancy pants. Okay, right. My previous job, I was at a Laravel partner, and we got a lot of consultancy work, and stuff would come in, and let me tell you, everybody, some of the code that I saw where people said, hello, please, come and help us. You look at it and go, oh, yes, you do need help. Because the first thing I saw on one of these things, I've obviously, for NDA reasons, have obscured like various bits of information, but that was the first thing that we saw in the routing file. So like, oh no, hit debug users because we're going to need to debug it because we don't have access to the database. Dump out. This isn't even about performance. This is just, what's this? And to be honest with you, when I see things like this, I hate this code as much as I hate Jar Jar Binks. And I really hate Jar Jar Binks, okay? I really do. Can't really convey how much I don't like Jar Jar Binks. Right, let's get onto the actual code of the performance bit. Get me some users and put them out into a dashboard. That's real. You think this thing about performance is like, yeah, but people aren't really that bad. This is real. Let's look at them. Number 1. That's not good. Why are you getting everything? Like, yes, get me everything from the database because they'll need all of the things. I think usually the result of this was supposed to be about, I don't know, like 25 users or something. Get me all of the things. Like, okay, you want 25 users with some conditions, but instead I will give you 1,000,000 rows and then you can sort through them. Next up, the for each is already created, like, okay, we're in n+1 territory. Now we're going to take out the settings from the relation, which we didn't get in the first place, and then we're going to get them. Okay? Well, that's not good. And then we're going to loop through the settings that we've already got out, and then this happens. I'm going to take the setting, get the contact back out, and then with the settings, I'm then going to... What? What are you doing? What's this? And honestly, I hate this code as much as I hate Jar Jar Binks, and I really hate Jar Jar Binks. Can't stand him. Can't believe that film came out in 2001, and it still haunts me. Oh, right, go on. Questions. How do we inspire me, Jim. Inspire me. Okay, good. Right. So, I went and thought, I'm going to talk to people about this. So I spoke to Thomas at Platform SH, who was also doing work at the moment in Blackfire, and we'll get onto that. I said, what is the biggest thing that you see with enterprise performance? They said, one of the biggest problems that we see is people try to get clever with tooling. That's what you saw before, Fastly, Solar, all bolted on, instead of engineers thinking about the code at the base level that they are writing. Similarly, if any of you have heard of Fathom Analytics, Fathom Analytics does an insane amount of requests in order to do what it does. And one of the things that, go and check out Fathom Analytics blog. It's really interesting engineering insights. But the thing that stands out is you try and do all of these fancy things, and you try and do, this is like people, especially from other languages, like we do this, we've got asynchronous, blah, blah. If you do all of this, it's fine, but your number one problem that you're going to encounter when it comes to performance when you scale up is going to be the bottleneck around your database. Should be sort of like sensible. What have we got? This isn't really a question, it's more of a statement. Oh, no, sorry, mate, sit down, not interested. Right, how do we change this? So, let's go into the tooling. Tooling is important. This is how we're going to do it, right? And one of the things that people sort of think of straight away is they think of application performance management. So things like this will come to mind, right? Things like New Relic or Datadog. But the whole performance code as you write it, and then the whole nightmare bolted on thing, this is bolting things on afterwards. This does not help us. This can help us with performance monitoring, but when you want to actually dig into the code that's making things not performant, if it's not front-end caching or whatever, yeah, this can do that, but the actual code itself, that's not going to help us. So, there are two paths that we can take to do this. And the first one, I like to call cheating. Always good. It's cheating because there are two tools out there that will do all of this for you. This probably won't come as a surprise to more senior people in the room, but if you've not heard of them, there is Tideways and there is Blackfire. And like a true engineer, I'm going to tell you advantages and disadvantages because it depends is always the answer. They're cloud-based SaaS. They have CI checks and thresholds and pipelines. You can set everything out. So when you do a pull request and you want to get it merged, one of these tools will then look and go, what is wrong with your code? Is the ORM being used correctly? Are you doing something horrible that should be cached, et cetera, et cetera? These tools are absolutely amazing at doing it. That's why they are what they are. And also, they have recommendation engines. And again, the recommendation engine is amazing. So what it sounds like is I've just sorted out our problem, but I've not sorted out our problem because there are disadvantages. and the disadvantages look like this. First of all, both of them, it's not really, no, I'm not accusing these companies of anything. It's just that naturally, because of the size of these things, there's a focus on enterprise. And so if you've got startups and you're booting something from Symfony Flex or you're using Laravel, this isn't really appropriate. And number one, like when I gave this talk recently in Austin, everybody nodded their head when I said, that is the main problem. They have spent a lot of money making that recommendation engine and the cloud SaaS amazingly good, yes, but because of that, you're not going to get it for free. It costs a lot of money. That's fine. That makes sense. So what I'm saying is from a base level now, we've actually got, that's not an instant path to success depending on your situation. So in that case, we have to take the hard path to doing this. And this is the mindset. And I have to get into the mindset of using things like AWS Infinidash. And I'm not going to explain why that's a cheap joke, but look up AWS Infinidash and what it does. It doesn't do anything, it's a joke. But what I'm trying to say is it's like DevOps practicing. It's a state of mind. It's process and how you approach things. So as a engineering lead, you have to think of performance, but you need to instill a culture within your team and your juniors on how to do it. So the most important thing when you're doing things in this kind of manual way is you need to set your expectations from your stakeholders of what is fast and what is not fast and what is acceptable and what is not acceptable from a technical point of view. That's the same if you use Blackfire, and it's the same if you use Tideways. You still need to set your threshold. If you have this muddle where no one knows whether it's like what is fast and things like that, it's not going to work. The biggest thing, and I've done this as a junior, the biggest drawback I've seen with performance all the time as a junior was I did not understand properly how to use the ORM. And that's either Doctrine or Eloquent, depending on which, right? I didn't understand the underlying SQL that's being generated. And a lot of people are coming into the industry right now in juniors where they don't understand SQL. They want the ORM to do it for them, but you need to have optimization. It's things like table scans and joins and things. You need to know how these things work. If your juniors don't understand these things, you're heading for performance nightmares. It will happen. And then you've got tech debt, and then you've got to clean it up. Custom cache layers as well. As we saw from the caches before, you've got to be super careful. That's the reason why I've put when to use them. Caches are great. Use them when appropriate, because I've seen them cache all of the things, and you're like, no, no. This, from Vonage's point of view, is very important because we are effectively a third-party API, and our new Verify API that we have, which does two-factor authentication, relies on webhooks that are asynchronous. I have, however, worked at a Shopify agency where all of the way that things were tied together was all synchronous. That was not considered. So they're like, okay, you can buy the thing, you can buy the sausages, but when you buy the sausages, then we also need to make a custom API call to the thing of how many sausages are in the sausage factory and things like that. Oh, wait. You're like, really? We're going to wait for what about the response? So not building things asynchronous, I've seen it done all over the place. That's the reason why things like this new API we've got is asynchronous, so that you don't have to wait. But you'd be amazed at how much blocking code people write when they're thinking about things like this. So I've given you two tools of how to do it. I've talked about the mindset. How do we do this with other tooling? And the answer is, of course, yes. Yes, we can. Here's how we do it. Option one. I did not know about this until I found it on Lorna Mitchell's blog, because I find seemingly everything on Lorna Mitchell's blog. I can't speak. XHProf by Tideways. So Tideways took on the original profiler that Facebook wrote, and it is open source. And you can use it for profiling. We'll get onto things like XDebug, because that has a profiler in a minute. But this is like, I tried it, and I was like, why isn't everybody doing this? This is amazing. Like, look at the fact that you've got the memory hogs where it's actually saying, oh, look, the output buffer there is the biggest thing. This is just what comes out of the box when you're profiling stuff. It's immensely powerful. And I'll talk about how you can still, like, where it comes into part of your culture in a minute. Similarly, though, you have another option, which you may be more familiar. The only problem is with this is that this is, so XDebug, if you're not using XDebug, I have one tip for you: use XDebug. That's it. If you're not using it, go and use it now. Although I could say that, but also Ray is extremely good, which is quite new. The profiler you can run It's obviously you have to be careful with how you switch it on and off, because if you leave it on in production, good luck. But this outputs a cache grind file, which is a type of proprietary file system. Well, it's an open file system. And then you can read it into something. The main thing that you do, this is kcache grind, which is like a Linux app. Yes, I know it looks like a screen from Jurassic Park. Once you get to know to actually read how this is working, it's immensely powerful. I do like this. It's very sort of like, no, I'm not going to try and understand that. But look at you've got how much execution time is running, and it will identify bottlenecks, particularly usually in things like loops or callbacks. What I'm saying with this tooling is, yes, it's complicated in the kind of chain of where you are in your team. If you're at the top, if you're a senior, if you're experienced, you'll be able to start reading these things. You then need to give the power to your juniors to also be able to do this. Once you do that, you will have a superhuman team, and I have seen it done. Trust me, it works. Another thing that I've not seen used out of the box in teams, which is absolutely mind-boggling, if you want something easier as an approach, if you use Laravel or Symfony, it's the debug bars. I was in a team where they're like, I'm gonna say it. They won't know. They won't be watching this. They actually said, we don't turn on the debug bars because otherwise you won't get experience, because it does it all for you. Don't say that ever. That's stupid. But you can be wrong if you want to. You can be wrong. It's fine. These are so powerful. I mean, out the box, Symfony's one, for instance. You've got a performance that gives you a proper Gantt chart of how it's running. Then you've got what's going on in your cache. You've got, probably most important for me, is usually a debugger for doctrine, for watching how your ORM is being used. When you want to identify things like N+1 problems, it will do it. If you have a setup with whatever it is for your local development environment, like a Docker type thing, and you give it to your juniors and say, all you do is Docker compose up, and then you put this flag in, you switch it on, why isn't everybody doing that? It's mental. And then you tell people, this is what it is, and this is how to read it. Instilling the culture will change how you ship software. Similarly, this is the Laravel one. Yeah, chalk and cheese. So, no, it's the opposite. It's apples and pears or whatever. I'm in London, sound like a Cockney. So, similarly, you've got here you've got how many queries are being executed by Eloquent, and you've got the most important thing. You can still do it with the Gantt chart stuff. You've got the performance time, right? That should be part of everybody's process, really. And I'm telling you this because I've seen it infinite times where it's not, which is just, I just don't understand. What's the next question? No. Why should we be doing PDD? Thank you. Why should we be doing it? Because it's like, that was part of the questions that I was saying like, right, okay, what is it and why should we be doing it? Why should we be doing it? I think you've probably got the gist now that the thing in developer advocacy that's most important to me is developer experience and leveling up juniors. Those are the things that are the most important. Because I have been a junior at many places, particularly agencies, and they are absolutely, some of them are amazing. Some of them are amazing. I have worked at terrible places, and I've been bullied. And it's not fun. Leveling up your juniors is very important to me, and having this kind of culture levels them up. But for your business side, this was the best one I could get. I'm sorry, it's from March 2016, which actually makes it more poignant. At the end of the day, performance. If you don't have it, people won't use your product. That's it. If you want, there's no business case to be that's complicated here. If you want to ship quality software, it's got to work fast. That's it. And what is it? Something like 3 seconds, 3 seconds to load. And like I said, that's from 2016. So why aren't we doing it? That's why you should be doing it. Performance is key, right? But understanding that you, as a senior, understanding how your code works in a performant way, and then instilling that into your juniors will make your team extremely powerful. And I have seen that done. And if you do it as a lead, this is you being a leader at the top, you then have the respect and you can mentor juniors. That makes you superhuman. And to me, culture around tech is just as important as the software itself. So, let's clean up our sausage factory. What does it look like now then? So I actually run the debug bar on it, and this is real. There's about 2 more records underneath there. So it's like, hey, I want like 10 records. And you're like, okay, I want 10 records. How much is that going to cost me? It's going to cost you 286 queries. It's going to take 11.92 seconds to load. Somebody came to me and said, this is live in production. And I'm like, oh no, you need my help. So, the cleaning up of it, I mean, like, to lots of you that are experienced, this will just, you'll look at it and go, well, that's obvious. But it's not obvious, that's the point. It's obvious to you maybe if you're experienced or senior, but to juniors it isn't. I mean, number one, no pagination in the whole app would be considered. So that's why it was fetching everything, because they're like, but I don't see all the things on the screen, I only see what I want. No understanding of what's happening underneath the hood. So instead, we'll say, give me the contacts with the settings, and then I'm going to do an actual where query on it and say, can phone equal, setting name can phone equals, equals there. Oh, whatever, you can read it. This is the second day of the conference, and as you know, for those who spoke to me at booth, my mum says I talk a lot. And there we go. This is what happens. But that's all I had was the Laravel debug bar and then an understanding of what was happening under the hood. So now it says, I want 10 records, and I will do 4 queries, and it will take 324 milliseconds. That is how you do performance-driven development. It sounds like it's some mysterious thing, and I was going to like wheel out some amazing product and go, I'm going to launch the Vonage Super. It's not. It's just that. That's all it is. Hopefully, some of you go, he's got a point, and some of you will say, that was a waste of my time. Hopefully, it's the former. Congratulations, you're winner. If you want to know what this is from an amazing video game in 2003 called Big Rigs Over the Road Racing. It was created in Russia, and watch a video of it in action. It's amazing. When I say amazing, I like bad things, okay? But congratulations, you've instilled performance-driven development. Well done, you're winner. Yeah, I know, I'm noisy. Can you wrap this on board of your anger? It's not real anger, it's like fake anger, I'm trying to explain my persona here. Let's not do that. I asked 2 questions. What is PDD? So let's answer them. The 2 questions are, what is it and why are you doing it? What is TD? It's a mindset of performance. It's first-class consideration. It's avoiding the classic nightmare, which is shipped all of the things, the 2 things we didn't consider are security and performance. Why would you do that? That's ridiculous. Works on my machine, etc. But also, there's not one bird that can kill all these. There's not one. There's not one stone that can kill all these birds or turn over the turn. I'm talking to yourself now, Jim. Choosing the right process and tooling for you is important. You have to use what is good for you. So when I said, yes, Blackfire and Tideways is expensive, you might come as a consultant into an enterprise project that's massive, and they're like, please fix it, and you can throw money at it. Learning those tools is also difficult because they're not easy to use because they do a lot of stuff well. But choose what is important and works for you because it depends, etc., etc. Why aren't you doing it? Why aren't you doing it? It's quite accusative, like, why aren't you doing it? Shipped it into production, mate. DevOps problem now. I've seen that done quite a lot. I wonder if DevOps people thought when the discipline was coming together, it was just going to be devs going, your problem now. Well, that's one reason. Is like, I write the code and I don't have to think about it. Whatever, you could do it. Instilling these things is not cheap in time or money, but time is probably the biggest factor here. It's complex to do all this, to either set up a big enterprise level thing and then set up Datadog or New Relic for the APM sort of side of it. And it's complicated to set up if you're going to do it from the mindset because you have to train all of your juniors in fairly advanced tooling, right? So that's why people go, I've worked at agencies where they're like, ship it out the door and we don't care if it works and there's no testing. Fun times. The cost is prohibitive. That's probably going to be one of the big things. Cost, yes, it can be either time or money. Usually in sort of agency environments, things like that, it's time. They just can't afford to. But all you're doing then is killing yourself and you're going to introduce a ton of tech debt. Seen it happen everywhere. And finally, this the same thing, right? It's not a problem. It's the same as with anything. It's like, we're not running tests properly, or you've never, like backups. It's that like backup thing. It's not a problem until it's like, oh no, production is on fire and burning. I didn't expect this. Why didn't I expect this? And I look at it and go, well, I mean, you should have done, right? But we need to get out of that for a start. You know, don't never ever assume everything is correct all the time. The other reason why, and really it's the last reason why I don't think that you're doing PDD, could well be because you Jar Jar Binks. I really hate Jar Jar Binks. Ugh. Ladies and gentlemen, thank you. I have been Jim Second. Actual questions.
Thank you, James. What a performance.
I'm a trained actor that went into software development. Can you tell?
Yeah, I believe we have sufficient time for questions. And yes, please. There we go.
The bit that please make it a question and not a statement.
What about, that was a great talk.
Thank you.
What about ChatGPT? Can we put classes in there and ask it to do performance analysis on it?
Actually, one of my colleagues the other day, did say, I'm writing a jest test. Check this out, Jim, and just handed it over and showed me ChatGPT. And he said, hey, ChatGPT, I wish they'd changed the letters. Write me a test. And I literally went, oh no, that's right. But my colleague Chuck over there said, here is a new API in Vonage, ChatGPT. Here is the endpoints. Please write it. And it was all wrong. So do not trust it yet. The other thing I've seen is people writing content in blogs. I've genuinely seen a blog, and I was like, I went to my manager, what's wrong with this? And he said, you know what it is, don't you? I was like, no, come on. So the answer to that is, no, we're not there yet. We can be lazy when Skynet happens and, you know, it all writes the code for us, and then we pretend and we compile and get out our swords and start blah. But for the moment, nah, I wouldn't trust it. Look up the Bing thing. Look up the Bing argument about what year it is, and you'll see we're not quite there yet. Also, the Bing thing was really aggressive as well, which kind of frightened me. I have sufficiently bamboozled everybody. There's no questions.
So what do you really hate about Jar Jar Binks?
Have you seen that? I would love to go to every conference and they say, I'm not going to ask you about your talk, but, and I'm like, stuff that matters. That's true. I'm like, I don't like him because he's a weird racist character and George Lucas forgot what made Star Wars actually good. That's a start. And also, like, have you seen the thing where he's supposedly a Sith Lord? That's really, really funny. But he's just rubbish, and it's like, oh no, I can't use it, I'm clumsy, and they're going, I've waited years for this, and this is what I'm being served with. And like, that's my problem. It can go sort of like further, but you know, it's just, and also the CGI is rubbish, isn't it? It's just like, it looks like a plasticine thing gone wrong. Nah. Anyway, that's it. I mean, I don't think I've got more to it. This is like, everyone's like, this is the worst insight I've ever heard at a talk. But there you go. Those are my thoughts on Jar Jar Binks.
All right. So everybody's happy, it appears. No? All right. Give another applause to James.
Thank you, everyone.
Thank you. Big time. All right. We change rooms and yeah.
Thank you. That was an excellent. I couldn't have asked for a better intro because that's basically exactly how I feel. Thank you all for being here. I realize it's the last slot before the keynote, and we're all probably a little bit sleepy. But this is a topic I'm very excited about, so I hope I can get you just as excited to keep us all a little bit awake. So my name is Pauline. You may have seen me at the Git Talk if you were in the Portaton yesterday. I am a freelance software engineer. I'm currently working in the autonomous aviation space. I am also a mom of a 2.5-year-old who you may have also seen walking around last night, actually. It's very cute. Clicker, yes. My hobbies include knitting, video games, long walks on the beach, and making segues to the topic at hand, which brings me to the bright and exciting future of the decentralized web. So before we get started, I want to get some sort of go through some definitions that are going to be relevant. So first of all, what does decentralized mean? What does it mean for a system to be decentralized? Well, if you read the talk description, you would know that this is not a blockchain talk. If you were expecting a blockchain talk, I'm very sorry. This is your cue to go to something else that might interest you more. But this is not a blockchain talk, and I had to add that little disclaimer because the term decentralized has, in recent years, kind of become synonymous with everything crypto and Web3, NFTs, and even the metaverse for unknown reasons. But something doesn't have to be decentralized, blockchain to be decentralized. And inversely, something that is made with blockchain technology isn't necessarily decentralized. Because all it means for something to be decentralized is that it's the opposite of centralized. Thank you, Clippy, that's very useful. So what does it mean for a system to be centralized? Well, something is centralized if it is managed in one central place. So that can be in terms of like data storage or computation or hosting, anything really. So it can be on all these different levels, which also means that a system can be partially centralized, but not completely. If you take one tiny side road to blockchain, last one, of course, blockchain technology is generally seen as a decentralized technology because it's about a distributed ledger, right? So all these transactions are validated in a distributed way. But then if you look at crypto exchanges where all these wallets are managed and identities are tied to wallets and money is kind of stored, that's all managed in a central place, right? So that part of it can be centralized even though the transactions are not. And so then decentralized is the opposite. A system that is decentralized is managed by multiple independent nodes. And by independent, I mean they don't exert any control over each other. And if we look at Mastodon, for instance, which a lot of you will probably know, Mastodon can be run independently by one node. So that's its own instance of Mastodon with its own set of users, its own set of moderation rules, but users on one, it's still connected to the rest of the nodes on the server, or on the network. So users on one instance of Mastodon can still connect with and follow people on other instances, right? Then there's one other term that's often kind of used interchangeably, but there's a slight nuance there, there's a slight difference in meaning, so I want to kind of cover it, because it is relevant, and that is the word distributed. This clicker is all the way at the back there. So when a system is distributed, it means it's spread out. So the nodes, it's still a network of different nodes, but they're not necessarily independent, but they usually share a responsibility. So that could be, again, data storage. So if there's a lot of data to be stored, and it's too much to store on one central server, you might choose to have a distributed system of data storage servers. It could also be that there's some really heavy computational task that needs to be achieved. So then you give this distributed network of nodes shared responsibility to achieve a certain task. One really big example that we all know is DNS. So DNS maps URLs to IP addresses, right? You type in a URL or well, a domain name rather, into your browser, and then name servers, a network, big distributed network of name servers, is responsible for mapping that domain name to an IP address so that your browser knows which server to go to, essentially. So if you've ever done your DNS settings for your own website, you'll have put in a name server, right? So that's basically you telling it that this name server is the one that knows how to map your domain name to an IP address. And that's a distributed system because it's responsible for mapping literally all the world's web traffic to IP addresses. So that's a massive task. So then you need a kind of a distributed system to take care of that. Now that we've got those definitions sorted out, I want to take you to the story of back to the story of the past of the web and also the present of the web and where it fits in to these kind of terms. So it all started in 1989 when Sir Tim Berners-Lee, together with other people and building on other foundational knowledge, of course, invented the World Wide Web. And you'll see this is a little historical logo that was created by one of his colleagues at CERN that I don't know if you can all see it very well in the back, but it has a little slogan. It says, "Let's share what we know." And that was really the concept. It was a knowledge sharing tool, and specifically, the goal was to be able to share knowledge with people who traditionally maybe wouldn't have had access to knowledge. So either people, who live under repressive governments, for instance, or people who economically, traditionally wouldn't be able to go to universities. So it was really supposed to be a tool for empowerment, for equity. Is really quite a political tool. That was the intention. And so it was built on three main foundational technologies, one of which was personal computers, another one of which was networking, and then another one of which was hypertext documents. So the idea was to take all these personal computers and connect them on a big global network and have them act as servers and expose hypertext documents to each other, right? And then you have a hypertext document that's served by one machine, and it will have a little hyperlink, and you can click through to the next hypertext document, which could be on the same node on this distributed network, which is what it is, or which is what it was, really. And then it would take you to this, you could explore more information as you went. And an example that really still reflects this very well, this concept, is Wikipedia. Who hasn't gone down a Wikipedia information hole? That was the whole idea. You discover knowledge as you go, but you do it through this big distributed network of all these different nodes serving up information for you to discover. So then it was unleashed on the world. And it was a huge catalyst, of course, to the information age, which is the one that we're in now, where information is a huge part of the economy. The modern economy rests on information, basically. And Sir Tim Berners-Lee, as you can see by his title, was knighted for this invention. So then it was unleashed on the world, and pretty soon all these little companies started popping up, offering small amounts of web space, because of course, for the average user, it wasn't so straightforward to host their own web server and start hosting these hypertext documents. So an easy way is to go to one of these companies, get some web space, and start hosting your personal homepage. So there was a lot of personal homepages, and it led to people learning about HTML, marquees, animated GIFs, all that good stuff, and it led to glorious internet culture and also awful internet culture. And a lot of useful information and a lot of not so useful information. And over time, people started finding ways of pushing the boundaries of this technology. So it started finding little features that they could exploit to make things more dynamic. So for instance, the XML HTTP request feature in Internet Explorer was discovered by people to enable you to make AJAX requests, so you can load data into your pages dynamically. Of course, famously, Rasmus invented PHP, which initially stood for personal homepage, as many of you will probably know. And the goal of that was really for a way to manage his own personal homepage by interacting with the server. So he would interact with the server, and then that would affect what his homepage would look like. And then he kept extending that and adding things like, also being able to communicate with the database so that you could persist things and show that on your homepage and stuff. And just grew and grew in popularity. And here we all are with our nice jobs and stuff. So it all became, it went from serving these hypertext documents to kind of applications, right? Users interacting with servers. And you can already peep him here. Tom was kind of the result of that. He was on the cusp of that. If you had MySpace, who doesn't know who Tom is? Oh, no clue? Nice. Okay, a few hands, but most of you know who Tom is. So Tom, if you were on MySpace, you would have known him as everyone's friend, because he was the founder of MySpace, and he was your first friend. It's very wholesome, very cute. But so he was kind of on the cusp of what we've come to call Web 2.0, which was the social web. So the social web was where people, instead of hosting their own personal homepages, would sign up to applications, and these applications would enable you to message each other, add each other as friends, and things like that. So all pretty fun and innocuous at the time. But pretty quickly, and if you were doing a degree in the mid-2000s to late 2000s like I was, you would have already started hearing this buzzword, big data. So big data, we all know this term now, of course, but at the time, I remember I was being taught that, and we didn't really fully understand why yet, we just knew it made money. So we were taught that if you're gonna start building web applications, what you wanna do is just gather as much behavioral user data as you can, even on data points that you might not think are very relevant, because you never know how they might be useful, basically. And it was very, very fruitful. It became the business model, and it still is the business model. Data is literally more valuable than gold. So big data is when we became the product, right? And the same guy who created that nice little logo before, Sir Tim Berners-Lee's colleague at CERN, Robert Caillot, he had some concerns even at the time. This is a quote from him where he's saying that his concern was that the client is the advertiser. So you as a user of these applications are not the client. They don't care about you as a customer, essentially. The client is the advertiser. You are the product. And what's worse is you don't have a contract with them. So basically what he was saying is you have this dynamic with them where you're the one making them money. You're offering yourself up on a silver platter, basically, and there's no agreement there as to the extent to which you can be used as a product. So he was very concerned about that, but we as the average users weren't very concerned about that at the time, so this was very lucrative, because everyone was on social media, still is, of course, but this has made those kind of early adopters and those early social companies wildly successful, and they started gobbling up all these other startups and gobbling up the competition. And so they started accessing basically all of our user data in central places. So like you saw before on the previous slide, you saw Facebook and Instagram. I think Instagram was bought at a point where they were only something like 10 employees or something, very small. Huge impact on the amount of data that Facebook has, for instance. Okay, so what's happened now is what was supposed to be a distributed network has become more and more centralized. So in 2018, FANG, what we now know as FANG, so the acronym Facebook, Amazon, Apple, Netflix, and Google, had control over 57% of all web traffic. That's in 2018. And all of this has had very serious consequences, reaching far beyond the realm of feeding us advertisements. For instance, just in terms of energy consumption, from 2018 to 2020, Fang's energy consumption tripled, leaving entire countries in the dust. So here you'll see that Peru, Portugal, and, well, Greece is slightly cut off, but they're behind Fang in terms of energy consumption. Fun fact, billions of liters of water per year are used to cool the servers in one giant Google data center. And keep in mind that also these data centers, some of them tend to be built in places that are very drought prone, so that's also not great. On top of that, this data is now being sold to much more nefarious ends than showing you advertisements. For instance, for mass surveillance, not just by your own government, but also other nation states that are spying on you, essentially. And personas of us are being created to do things like swing elections and deliver meticulously targeted propaganda to our kids. And also to share propaganda with us to incite hatred to the point of actual genocide. And all of these are real. All of these are real, and they're just a smidgen of what I could have pulled up. So very, very far-reaching consequences. To the point that Sir Tim Berners-Lee, the same Sir Tim Berners-Lee who invented the web, has now said that his invention is no longer used as a source for good, as a force for good. I don't know why that was. So in 2018, he posted an open letter to the public, basically warning us about that, and that his invention had been perverted, and that it's been weaponized against us. And that sounds very intense, but if you look at the examples before and many others, you'll know that it's true. And now you might think, Pauline, this isn't the bright and exciting future that you were talking about, is it? This doesn't sound bright and exciting at all. And you're right, it doesn't sound very bright and exciting. But so far, we've only talked about the past and the present. And this talk is about the future. And for the future, Sir Tim Berners-Lee has a bold plan to flip the web the right side up again. So this plan is called the SOLID project. And SOLID stands for social linked data. And it has a few different components, one of which is a specification. So that's the social linked data specification. That is meant to represent concepts from online life and also real life. And the other component is the pods. That sounds very vague. But pods are essentially just web servers, and the aim is that every user will have their own web server for data storage, so for storing their personal data. Not just personal data, but just any behavioral data. Okay, so the aim is for none of this data to be stored on these external servers anymore, but to be stored on your own pod, and then you expose that data to the apps that you use. So let's take, so this is your pod, yes, hi. So that's your little web server. And let's say you're using a music streaming service. So this music streaming service, you give it read access to your name for your profile and to your address because you have a subscription with them, so they need your billing address, okay? And in turn, it gets write access to your pod to write your listens and your favorites to your pod. Now let's say you're also using an event app. So this event app also has read access to your name for your profile and to the city out of your address. So not your entire address, but the city out of your address. Then it also has read access to your listens and favorites that have been written to your pod by the streaming service or any other service that you're also using that's also writing to this particular object from the spec, basically. So based on those read permissions, that app can then recommend concerts in your area. So you're getting the same value that you had before, but they're not storing any of your behavioral data. That's the concept. Okay? Then another bit of added value, so this is the same value for the user. Another bit of added value that this would bring is interoperability. So let's say your address changes. You can then change your address either by managing your pod directly and changing your address, or with an app that you may have given right permissions to your address. And then once you update that, all the applications that have read access to your address will be updated. So you only have to update it in one place. So it aims to kind of give you control back over your data and keep it so you can keep it close to you, but also add some value for you as a user to make it more attractive for you as well. Because what you can then also do, for instance, is if you cancel your subscription with the streaming service, they won't need your billing address anymore. So you remove access, stuff like that. And I think this idea is really exciting and really promising, because if I think about my online life, you know, since a preteen, I was on the internet since I was a preteen. And I've made posts online when I was 12, you know, put my personal data online, and it's all out there somewhere. I've had Twitter since 2009. I have no idea what's on my Twitter on 2009. And what's worse, now that Elon Musk has bought it, he's made the API no longer free and is charging pretty extortionate amounts to use the API. So a lot of people, what they were doing was automatically deleting their tweets. You can't do that anymore now. So I really like the idea of being able to just take all that information, you have it close to you, and you just cut off access to whatever. Especially having a kid now, I really am kind of fearful for the idea that when she starts going on the internet, you know, she's 2.5 now, that all of her photos are online, you know, everything that she's ever posted is online, and she has no control over it. Once it's out there, it's going to be duplicated into Affinity, sold off, you know, it's out there forever. We all know this. But this could be a solution to that. So I think it's really promising. It's still very early days, but it's very promising. And you can already get your own pod. There's a few options. So one option is to host your own, which for the average user, I mean, it definitely has some technical overhead, because you're basically just running a web server. So you have to take into account everything that you would have to take into account if you're running a web server, right? It's also not the most user-friendly yet, but they're supposedly working on that. I don't know what that means and what the time frame there is, but I think that most people are hosting their pods in a similar way that you used to host your home pages on things like GeoCities. So you're still hosting it in the cloud, essentially, but the difference is that you can extract your pod and move it anywhere else whenever you please, basically. So there's two pretty popular options. One is the hosted community server. So that's my web ID on there. It's still a little bit wonky, I think, user interface-wise. But there's also Inrupt, and Inrupt is the company that Tim Berners-Lee, Sir Tim Berners-Lee, put some respect on his name. He started this company in 2017 to kind of be able to propel the Solid project forward, and to kind of also offer enterprise solutions, and be able to raise funding. So up until now, so from 2017 until now, they've raised almost up to 50 million euros, I think. Euros or dollars or pounds? Anyway, 50 million. I think with numbers that big, it probably doesn't really matter that much anyway. So pretty significant amounts already. And also, fun fact, the Flemish government, so that's the Dutch-speaking part of Belgium, has already said they were going to invest in a pod for each of their citizens. So all of their citizens are going to get a pod to manage their government affairs, and whatever other affairs they want to manage through their pod, of course. And a little closer to home, the NHS has also bought into the idea. So patients are going to be able to manage their medical information on these pods, which is very attractive, of course, with that kind of data, because there's little more sensitive than medical information, right? So very exciting. If you want to read about more options to get your own pod, there's a little pop-up with a QR code. I don't know if they're big enough for the back I sure hope so. Does that work? Can I get an eye from the back somewhere? Middle is good. Okay, back is pretty good. Sweet, because I've got a few more in there, so that's very helpful. All right, let's dismiss this pop-up and move on to the Fediverse. So hands up if you've heard of the Fediverse. Keep your hand up if you are on Mastodon. That's pretty much the same amount of people. And that doesn't surprise me, because Mastodon is by far the most used and most widely known Fediverse app out there today. And that is because Elon Musk recently bought Twitter for reasons, and a lot of people started making an exodus. Specifically, a lot of technologists, a lot of privacy-conscious people, a lot of journalists started making their way out and finding decentralized alternatives. And the Fediverse is an interconnected kind of network of federated applications. Okay, what does that mean? Okay, so federation, another fun definition. I'm going to try to explain federation with a few examples, 2 examples. So we already knew about Mastodon, right? So Mastodon is a decentralized microblogging platform like Twitter. You can blog by means of posting very small messages. And it's set up in a way that it's many independent nodes on a network. So one node is an independent instance of Mastodon, and you can join an instance that interests you, but that doesn't mean that you're limited to that instance. So you can still follow people on other instances, right? Now let's take another Fediverse app, Write Freely. So less popular, but still fairly popular. So Write Freely is a decentralized blogging platform, and it's kind of a clean blogging platform. So the aim is to be able to blog in a kind of a distraction-free environment. So very clean interface, you know, black text on a white background, no likes, no comments, no claps, nothing like that, just clean blogging. And it's set up exactly like Mastodon in the sense that there are instances of this application, and you can join an instance, but you can still follow other people. Where federation becomes really interesting is in the fact that both of these use the same protocol called the ActivityPub protocol. So ActivityPub, the protocol, is a little bit reminiscent of this solid specification that we were talking about before. It represents concepts from social media, so like profiles and posts and likes and things like that. And the thing is, what makes this so fun is, okay, so let's say my mom likes to share her cookie recipes and she likes to use Write Freely for it. She has an account on WriteAs, which is a Write Freely instance. She writes her posts there, and Write Freely uses, for posts, uses the same object, ActivityPub object, as Mastodon uses for its toots. Yes, that's what they're called. They're called toots on Mastodon. So they're both using the note object in ActivityPub, which means that through this protocol, if my mother has enabled federation, I can follow her on Mastodon, but she is not on Mastodon. I can follow her on Mastodon, and her posts will show up as toots on my timeline. So that's really interesting. And that's one thing that I think a lot of people don't realize, because what a lot of people think, especially in the context of Twitter and Mastodon, they think, oh, here's a Twitter clone. Oh, here's a Reddit clone. There's all of these different clones, right? But they're decentralized. And a lot of people, I don't think, are aware what this federation means in terms of this. Because decentralization to the average user doesn't really mean much, right? But this is a completely different way of sharing content, because now you can follow your friends and family even if they decide to use a different application that you're not using. So, I mean, everyone over 25 here probably will find it relatable that you have a little bit of FOMO because you hear all these kids on TikTok are making really fun content, but, you know, personally, I don't really get TikTok very much, but it'd be nice if I could still follow that content and just stay on my own little app. So that's really interesting to me. Another very interesting it's not new, but another different way of sharing content is a thing called IPFS. So IPFS is partially a protocol. As you can see here, IPFS : / reminds you of HTTP, right? It stands for Interplanetary File System, which is just the cutest name. I love it. But it is partially meant to replace HTTP. So it's partially a protocol, but it's also a peer-to-peer file sharing network. So a bit like what you're used to from like BitTorrent, for instance, right? Where there's you're looking for a file, and it's hosted by many different peers, and then you request that file, and then all those peers kind of come together and put bits together, and then you have the file. So that's the idea. But so it's also a browser protocol. So instead of HTTP, you put this in, and this is natively supported by, I don't know if anyone's using Brave, the browser. Yeah, a few people, a few nods. Also, if you're using Firefox or Chromium, it has an extension to support IPFS. And so what happens is a resource is not hosted by one server. It's hosted by many peers. So it's chunked up, cryptographically hashed, and then based on this hash, a content identifier is created, so a CID. And so you take that COD, and that is how you access the file, and then the network goes and gets all these different chunks from nodes on the network and serves you that. What's also fun is that this CID, because it's based on a content hash, when the content changes, so does the CID. So if you have a certain CID, you are guaranteed to have get that specific version and not a different version. But you can still also ensure that you get the latest version through a DNS link. So in a similar way that you have the domain name mapping to an IP address, you can have a readable address pointing to the freshest CID, basically, so that you can be sure that you have the latest version of a specific file. And what's very nice about this is that it's resistant to censorship, because it's not hosted on one server. A government can't just come over to your house and go, hey, take this down, and do like a takedown request, because there's plenty of other peers that are also hosting the same content, right? And that is becoming increasingly important, because as the web has centralized more and more, governments have started restricting access more easily, right? So famously, Russia has blocked Facebook and Twitter at the beginning of the invasion in Ukraine to stop people from reading fake news about the war, according to them. Then also Iran has been doing this for a while now, restricting access to Facebook and websites like that. But now, after the recent political upheaval, they've even started considering blocking all non-domestic internet, which is unprecedented levels of censorship, basically. But it's not just these kind of what you would think are really repressive governments. It's basically every government. So here's Poland is one example, but Norway also, the US, probably your governments as well. Basically, every government is participating in some level of internet censorship, usually after some sort of political upheaval, after specific campaigns, in response to activists organizing. Why? Because they can now, because it's increasingly easier, because you only have to block specific centralized entities, and because they know that the internet is an excellent tool for people to organize. Make no mistake, the internet is a very political tool. It was intended that way as well. And so that's why they restrict access, because they know it's a tool and they can do it. And that's why I think it's so important for us as people, for you as people, if you ever need to organize, you need to be able to do that. And that's why it's important for us to start taking all of this apart now. So how can you get involved? Well, the easiest and most immediate way for you to get involved is to start using decentralized apps, to start using alternatives to these walled gardens. If you need some help with that, there's a really great website called switching.software that has a nice curated list of things that are, not all of them are federated or decentralized, but they're all either more ethical, more privacy conscious, and they're curated to also be user-friendly alternatives, which is also quite important. Another one is to teach people. I'm very excited about this subject, and that's why I wanted to give a talk about it. I think it's very important that we tell people the importance of decentralizing the web and what it actually involves, because it is very important. So tell everyone you know. Start building apps for the Solid project. Just try it out. Start building apps using the ActivityPub protocol, which for PHP developers is fairly accessible, because Kevin Dungla, I don't know if I'm sure some people know him. He's one of the founders of API Platform. He's also a core developer on a bunch of Symfony bundles. He's very into this decentralized web thing, and he has added support to API Platform for ActivityPub. So if you want to make an ActivityPub app as a PHP developer, that's a really good way to start. Then you can also contribute to the things that already exist. So especially the Solid project is very early days. This community server, one way to garner a lot of interest in these things is to have very user-friendly applications. So if you have a good feel for that, please do contribute. One thing I would love to see also is for the Solid project to start supporting ActivityPub. Because how great would it be if I were to be able to use Mastodon, but I don't give all my toots to some random person running an instance. I keep it on my own pod, and I use a federated app. I think that would be great. So there's also an issue open there, because it's a big issue, but it would be great if people started tackling that. But before you get started, I just want to say one more thing. There's this thing called DWeb, and it's kind of an umbrella community for everything decentralized web that has started up around the Internet Archive, who is very interested in remaining existent. So they're really looking into this peer-to-peer hosting to ensure the archive's existence. But it's become kind of a global community around the decentralized web, and they have a very specific aim, and that is to become a web with many winners and to return to the original vision of the World Wide Web. Okay, so they acknowledge that a technology isn't necessarily a solution to a societal problem, as we've seen, but it can also aggravate societal problems. So what they're saying is we have to be very conscious. We have a chance to do this, to have a do-over, but we have to be very conscious of how we do it. So they've created a set of principles. I'll go through them very quick, because I think, we have 10 minutes total. So they're divided in a few, less or more? Oh, more. Oh, great. Okay, I'll be really slow. Okay. Okay, great. So they're divided in a few main kind of topics. One of them is the technology for human agency. So the purpose of technology should be for human agency, meaning that the web and any other type of technology should be a tool, a communication tool for peer-to-peer, person-to-person communication, not through hierarchical power structures, and not through like hierarchical monitoring and control. So it should be peer-to-peer. The technology should serve people as a community, communication tool. Second, distributed benefits, meaning that the benefits that are being reaped from a technology should go to the people participating in that technology, or, well, the community at large, and not to a few early adopters, not to a few tech giants, and that I think is what we've been seeing in the I'm a bit of a crypto skeptic, and it's partially because we've been seeing in the crypto space, it started with this kind of similar idealism, right, of wanting to decentralize things and wanting to dismantle power structures. But what it's become of late it's really become disproportionately about wealth acquisition and about speculation. And you're seeing that a lot of these early adopters have become ridiculously wealthy and ridiculously powerful in the space. So then you gotta wonder, aren't we emulating exactly the thing that we were trying to avoid, that we were trying to dismantle, right? So distributed benefits is a really crucial part of the set of principles. Wealth should flow to the community at large, not to the lucky few, basically. 3, mutual respect. So because all of this is decentralized, there is no central body that kind of mandates behavior and things like that. So if you are running an instance, for instance, you should have a clear code of conduct. You should organize in a transparent way so that users know that abuse won't be common. Everyone's beliefs are respected. You get what I mean. There's no room for abuse. Users can feel safe and confident that they will be treated with respect on these decentralized applications. Humanity. So the focus of the web should be on human rights. It should be on empowering people, like it was. It should be about equity. So it should be empowering, especially to those who have traditionally been oppressed. So we have to, instead of just building anything, we have to build with that in mind, and we have to build in mechanisms for harm reduction. We have to build in mechanisms that mitigate exploitation and abuse of people. And finally, ecological awareness. So when we build anything, we need to keep in mind resource management. We need to keep in mind the impact on the environment that our technology has. We also need to keep in mind things like the right to repair. People should, when they use something, should have some sort of agency over the technology that they use so that they can fix things instead of having to, after a while, throw something out and buy something new, because that also has an ecological impact, right? So that's basically, in a nutshell, the principles. If you want to read all of them, here's another QR code. This will take you to the DWeb website so you can read their principles. But again, I want to stress again that their mission is to go back to what the web was intended to be. These principles aren't new, and this is what Sir Tim Berners-Lee et al. Intended to create with the web. And he's actually very vocal about that. I'm not making that up. He's very vocal about that. So again, we have a chance at a do-over, and that is very possibly very bright and exciting. But we have to always remain critical for this to work. We always have to keep asking ourselves the difficult questions. That means that, as this starts to evolve and as you start learning and building things, be aware that you don't get too swept up in the excitement of something new, because then you're not critical anymore. You have to ask yourself the difficult questions like, does this particular technology have any disadvantages? Does this exciting new thing, idea that I have for something to build, does that in any way go against these principles? And then if it does, should I be building it at all? Should I maybe just let it go? So I think if we keep that in mind, then the future of the decentralized web can be much more bright and exciting than the dystopian dumpster fire that we have now. Thank you.
Wow, 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 wow. This was good, wasn't it? So we learned something new and opportunities. And so, who has questions?
So you talked about the distribution of files and making sure they can't be blocked by repressive regimes. I'm not saying it's necessarily balancing, but what about the situations where it's like material which is harmful? how do you stop that without also stopping the government, stopping things that they think are harmful?
Yep.
Is that something that's been discussed?
Yeah, it is. Although, and this is exactly why I'm saying we have to keep asking the difficult questions, because this is exactly the same concern that I have. So what happens is, basically, if you're hosting a piece of content, you can pin it if you want to keep it. So if you're a hosting peer who has discovered that they're hosting illegal content, you can unpin it, and then it gets garbage collected and nobody starts. But my issue with that is that is for the individual to kind of cushion themselves against doing anything illegal. It doesn't necessarily protect like the victims of for instance, revenge porn or child pornography or anything like that. And the thing is, they do think about it. So their solution to this basically is that you can the nodes are always very visible, so you can do takedown requests of the nodes. My concern is that this CID is very, how do I say it? If you have a URL, traditional URL posting to a file, of course it can be spread around loads. But if there's one URL that's been spread, one specific URL that's been widely spread, then it's only one takedown request and then that URL is gone. The data might still be hosted somewhere, but not so many people know about it. With the CID, you can do all these takedown requests, but you only need the one CID that's pointing to this content, you know? So I still feel a bit iffy about that myself as well.
What about the NHS keeping or putting records onto the pods?
Mm-hmm.
I assume they're going to also keep a copy as well, because I imagine end users might lose their pods, lose access, delete their own pods. I'm assuming it's going to be a duplication of data in that particular case.
From what I gather, the NHS has a contract with Inrupt, so it would be hosted by Inrupt, which I don't know how they handle duplication and things like that. But yeah, I don't think they're going to host the pods themselves, so it's all going to be Inrupt managing that, and I'm assuming that would stay there and you have full agency over it, but I'm not totally sure about how they handle that.
Anyone else?
It's basically two things. Like the first thing you kind of answered already, but maybe you want to elaborate more on that. You talked about censorship and all the problems that you have with state censorship, and I completely agree about that. But the flip side is content takedowns for things that you want to take down. But I basically answered that, and it's just one of the biggest problems I see with the whole Fediverse, that this is not solved yet.
Yeah.
The second thing, maybe you know, with the concept of pods, you actually have a central place where a lot of data of an individual person is stored, even if you can freely choose where that data is stored, is a prime target for attackers. So security is very, very vital there.
Mm-hmm.
And I can see so many problems coming out of that if that pod is somehow corrupted.
Yep.
Is there something in the protocol in Solid or of Inrupt where they're trying to address that?
Yeah, that's a very good question. I had the same concerns. I think the protocol is still, or the specification rather, is still lacking in a lot of ways. I don't think right now part of what is specified is that data is encrypted or anything like that, for instance. So I think it's still very much evolving. And there's still like a working group that's working on it. But I don't think at this point probably that's defined enough for everyone to comfortably go, oh, this isn't going to be an attack vector for all of my personal data. On the flip side, what happens now is, I don't know, well, you're probably using Have I Been Pooned? Like most, yeah. So on the flip side, I don't know how many notifications you're getting, but I'm constantly being notified of data breaches. So yeah, it's a little bit of a, we're getting these data breaches now as well, but I agree that that if you're going to put all of your very sensitive personal data, I would also want to know that it's a little bit more security conscious. Yeah.
when it comes to the pods and storing our data, it seems pretty unlikely to me that Netflix are ever going to say, "Oh, no problem. Yes, we'll put all their stuff on the pods," or Google or Facebook. And ultimately, the real offenders are the Google, the Facebook, and the Netflix, and so forth. Is there a plan to, in some way, get it, move it along so that actually that can happen?
Yeah, so that's actually a big kind of point of resistance that they have now, is that it's much more challenging to find a completely new business model where there was basically a one size fits all business model for selling data, right? So it's quite difficult to convince these commercial parties that this is what they want to do, because that's their bread and butter. It's much easier to go for governments and medical institutions. So that's essentially what Erupt is doing now, is they are really approaching those people and trying to make the difference there, and hopefully then slowly get enough critical mass so that and also try to give added value for users over having their data stored with a third party, such as that interoperability. And they're hoping that the combination of that, plus more people thinking about new business models, will eventually turn it into something that is viable. But yeah, again, it's very early days, so I really hope we can find ways to make this a thing.
When it comes to this pod system, from what I understand, the idea is that I can have one pod where I store all my data, so I can then change like my address, and then it's populated to everyone consuming that. But obviously, if you have systems like where the NHS is providing a pod with my medical data, and then you've got some government doing this in another place, then I can see that obviously that results in multiple pods having data, which is kind of against the principle, right? So how would that affect adoption, and is there any kind of idea that they have to ensure that this doesn't happen, that you have data in 20 different pods, basically?
Well, the concept would be for it to not be a medical data pod. It's basically they're giving you a pod for their purpose of managing medical data, but for you it's supposed to be your pod essentially. So it's not, the concept is not like, oh, I have my pod here for medical data and I have another pod. It's really when you have a pod, that's your pod. I do have multiple pods now because I've wanted to try different hosts, and I can also imagine a scenario where maybe you want to have like a different profile per activity, like one work pod and one. I could see that happening, but yeah, it's definitely not the idea that you're going to have a different pod for each purpose. Does that answer it? Ish.
Hi, I'm wondering what the recipe is.
The cookie recipe. Google speculationsrecept. And it's like the first allerhande recipe you can find. So, sorry, non-Dutch people.
Anyone else? There we go.
Huh? My mom also doesn't actually like to bake, so that was completely made up.
Hi. There's going to be a cost to running a pod, either to the individual or the person, organisation providing it. Is there any consideration to the risk of, say, a company like Google, which has got lots of infrastructure and could, say, host your pod for you in exchange for all the data inside of it to give you personalised ads and recommendations?
Well, I think if you go to the options list, you'll find that actually all the options list where they're hosted as well, and a lot of the options are actually hosted on AWS or Google Cloud. So that already is the case. I don't think it's going to be a deal of like, give me all of your data. I mean, I'd hope not. I guess anything is possible, but I don't think that is going to happen. What is happening as like a business model for Erupt right now is that you can have a free pod as a user with Erupt. You don't have to pay for it, and their business model is really from the enterprise solutions that they have. So that is what they're doing. So I imagine it'd be something like that. Maybe the community server could run on donations, who knows? But yeah. Does that make sense?
Anyone else?
Thanks for a great talk. I've had a lot of conversations with non-technical people where I get the response like, "Oh, but I have nothing to hide. I have nothing to worry about." How do you talk to non-technical people about this? Do you have good tips, good experiences, anything you can share?
Yeah, so my boyfriend is actually the best, how do I say this? Now I won't say a test subject. How do I not dehumanize him? Especially when I was writing this talk, obviously I was very excited and sharing stuff with him. So he tried this blogging platform and stuff because he liked just the value that gave him. He liked the idea of just very plain, no algorithms, no ads. Clearly you could have ads if you wanted to on your platform, but a lot of these things don't. So I think, and also with the federation concept, the whole cookie recipe thing, I think the added value there for the average user could be a selling point. The problem that I see with my test subject is that he'll then be attracted to the value that is given, but then when he starts using it, at this point it's so bare bones and it's so, there's no capitalist commercial driving force to ensure that users, for instance, aren't, they're trying to convert users, so they're not being stopped by bad user interface and stuff like that. So you do see that a lot. So that's what I see now. There is added value for the average user, but then when they arrive on this platform, they'll be quickly turned off by it because of the state it's in now. But I think that's just an early tech symptom. I think the early web had the very same thing, and then solutions started popping up. So I really hope that's going to be the case in the future as well.
All right. Thank you, Pauline.
Thank you.